spot. The knife I have is not the
Get
spot.
out.
Okay, it's not. Okay, I think it's all better.
Sorry, can you get See, there's a security guard sleeping. What will it take?
Love it.
You love us.
Oh, yeah.
Oh, Capuchon.
It's fine.
Now start to maybe on the rest.
Come here, man. We don't watch.
Alright, I think it's fine. I think it's fine now. I think it's fine now. So please, please, let's try to keep our voice down. Keep your voice down, okay? So let's start. Now let me check it now and see if there's any disturbance. Check it now and see if there's any disturbance. Check it now and see if there's any disturbance. Can you hear me from the? Let me check.
Check
From
now. Check.
the YouTube channel. Can you hear me? It's okay now, Abi? Okay. So we will do a little revision on each of these things. I beg any comments. We're going to do a little revision on each of these things. I know we've gone through these topics already, so I'll briefly go through them. I will solve questions on dimensions, scalar and vectors, kinematics, and dynamics rather, Newton's law, and circular motion. Is this clear?
Yes.
So let's start with the first one. The first one we have here is dimensions. I believe everybody, I need a duster. Sharp. I believe everybody here has an idea on dimensions. Yes or yes?
Yes.
Good. Now dimensions come from a topic called measurements. Thank you. Measurements and units. Okay? Measurement and units. So let's briefly talk about measurements and units, then we move straight to talking about dimensions. Are we together? When you say measurement, what does this tell us? What does measurement tell us? What does it mean? Anyone? Measurement. What is measurement? Measurement simply means estimation. To estimate the value of something means to measure that thing. Are we together? And anything that can be measured or estimated is termed as a quantity. It's termed as a what? A quantity. For example, can you measure the speed of a car?
Yes.
The speed of a car. Can you measure it? Now, since speed of a car can be measured, that means that speed is a what? Is a quantity. Do you understand that? Can you measure the volume of water?
Yes.
Since the volume of water can be measured, then volume is a what? Is a quantity. So basically in measurement, we simply estimate the values of quantities. Do you understand what I'm saying? So we have different kinds of quantities. We can have volume. We can have volume. We can have temperature. Are we here? We have volume, we have temperature, we have pressure, and the rest of them. Okay? So what do you call this thing that can be measured? What do you call them? Anything can measure are called what? Quantities. We can measure the force applied to push a car. So force is a what? Is a quantity. We can measure the tension in a string. So tension is a what? Is a quantity. Do you understand that? So basically we have different types of quantity. Basically we have three. In secondary school, they gave you two. They mentioned fundamental and derived. For university here, I'm going to give you how many quantities? Three quantities. The first one we have is called the fundamental quantity. Second one we have is called the what? Derived quantity. And the last one we have is called the supplementary quantity. This is a revision class. That means that I won't dive too deep into any topics. I will only give you a surface and you solve questions. Are we getting that? So the first one, fundamental. The word fundamental means what? Main. Abi? The main quantities are the fundamental quantities. Basically, how many do we have? We have 7. You have how many? 7. There are 7 fundamental quantities. Let me clear this. There are 7 fundamental quantities. Number 1 we have is mass. Number 2 we have is length. Number 3 we have time. Number 4 we have temperature. Number 5 we have current. Number 6 we have amount of substance. Why number 7 we have, who can tell me? We have what? Luminous intensity. So please, these are the 7 fundamental quantities we have. Any other quantity that is not here is not a fundamental quantity. Example 1. Which of the following, right? Which of the following is not a fundamental quantity? Which of the following is not a fundamental quantity? A. Weight. B. Mass. C. Temperature. And D. Current. What's your answer? Weight. So it may sound very funny to you. Gravity here. This is very simple. But this one, yes, as simple as this thing is, a lot of people fail it. Okay? So anyone that is not part of this 7 is not a fundamental quantity. Again, let's go. The 7 fundamental quantities we have: 1, mass; 2, length; 3, time; 4, temperature; 4, 5, current; 6, and 7, luminous intensity. Okay? The next kind of quantity we have is what? Derived quantities. As the word implies, derived, that means it's gotten from other quantities. It's gotten from 1 or 2 fundamental quantities. Give me an example. Area, volume, force, velocity, pressure, acceleration. Any other quantity that is not here is a what? Is a derived quantity. Okay, except 2. Okay, the other 2 are called supplementary quantities. Supplementary quantities are quantities of shapes of, let me say, of geometry of circles. So the quantity of the geometry of circles are called what? Supplementary quantities. Are we getting that? And there are only how many? 2. Number 1, the board is not so big, so I have to always. Number 1 we have is plane angle. And number 2 we have is solid angle. These are the 2 what? Are they derived? No. Are they derived? No. Are they fundamental? No. They are what? Supplementary. Which means that they are the geometry of circles. There are quantities of geometry of circles. Are you getting that? So we have plane angle and we have solid angle. So you get the 3 quantities we have: fundamental, derived, and what? Supplementary quantities. Are we getting that now? Now every quantity has a magnitude. For example, mass. Is mass fundamental, derived, or supplementary? It's what? Fundamental. If I don't know if you have done that thing before, you stand on one scale, you now read, you now see maybe 72 kg, have you? Yes. Or you see something that as light as feather, you see 19 kg, something you see 20 kg. That thing that is reading, that value is called a magnitude. It's called what? A magnitude. So every quantity must have a magnitude. Okay? The magnitude of that quantity is what we call units. Does that make sense? The magnitude of the quantity, how large a quantity is the unit of that quantity. So if I give you a value and I say the mass of an object is 10 kg, this thing you are seeing here is the unit of that mass. I say my weight is 100 Newton. This thing you are seeing here is the magnitude of my weight. So that magnitude of my weight is called what now? It's called units. It's called what? Units. So for units, you usually have a number and have a letter, something like this. But basically, we deal with this over here. Okay? So that means the units, that means that every quantity we have, we definitely have what? A unit. For example, the unit of mass is obviously what? Kilogram. The unit of weight is what? Is Newton. So every quantity have a unit, but not all quantities. Look at quantities like coefficient of friction. It does not have a unit. quantities like relative atomic mass in chemistry, quantities like relative density. They don't have what? They don't have units. Do you understand? But most quantities, most of them that we deal with in sciences have what? Have units. So it will be very, very wrong. As science students, what you need to know, you have to, whenever you are solving anything, that unit is very, very important. It's one of the most important things when you are solving, when you are doing your calculations. Are we getting that now? Let's talk about the units of these quantities. Are we together now? So let's start with fundamental units. What are fundamental units? They are the units of fundamental quantities. Do you understand that? What are derived units? They are the units of derived quantities. What are supplementary units? They are the units of supplementary. Do you understand that now? So every quantity will have its own units. Let's first deal with the unit of fundamental quantities. Are we getting that? So we call them fundamental units. Now, every quantity can have multiple units. For example, your mass can be measured in grams, yes? Can be measured in milligram, can be measured in kilogram. Do you understand? Can be measured in microgram. Different units, okay? But one of them is the most acceptable. That one is called the Standard International Unit, or SI units. Are you getting that? So a group of scientists, myself and people like Albert Einstein, we came together, and if you laugh, we came together and we agreed that let the unit of mass be what? Kilogram. So we picked kilogram as the unit of mass out of all the units that we have. Are we getting that now? So every quantity here have a unit. So let's start with mass. So what's the unit of mass again? Kilogram. So mass is kilogram. Length is what? Now length also have multiple units. It has meter, it has millimeter, kilometer, nanometer, millimita, so one of them is the most acceptable, which is what? Meter. So the unit of length is meter. The unit of time is seconds. Let's speed it up. The unit of temperature is what? And temperature has a lot of units. It has my laptop is there. Please. It has what do you call it? It has degrees Celsius. Please let me pack it. It has degree. Put it inside my bag. Put it inside the bag. It has degrees Celsius, it has Kelvin, and it has what? Fahrenheit. But the most acceptable here is what? Kelvin. K. Okay? Current is ampere. A. Amount of substance is mole. MOL. And luminous intensity is what? Candela. CD. So CD here represents what? Candela. So those are the fundamental units of these fundamental quantities. Do you understand what I'm saying? Good. So let's move to the unit of derived. Are these ones clear?
Yes.
Okay, good. Let's move straight to the units of derived quantities. The units of derived quantities. For the sake of time, I only treat four derived quantities. Anyone you give me four derived quantities, I'll give you the units. Give me four derived quantities. Four. Yeah. Number one. Give me four derived quantities. Force. Okay, one.
Viscosity.
Viscosity. What's viscosity? It's still force. Viscosity is talking about what? Force. So give me something else. What's in the Acceleration. Surface tension. Number three. Surface tension. Speed.
Density.
Okay, no problem. You said speed, I'll give you speed. Sorry. Speed and what? Last one. Okay, give me one more.
Density.
Okay. Give me one more. Density. So these are all derived what now? They are all derived quantities. So let's see the derived units for these derived quantities. Are we getting that? Yeah. Now for you to get the derived units, you have to know the formula. You understand? The formula. So let's go. What is the formula for force? Force is simply mass times acceleration. Mass times acceleration. Is it clear? Okay. Mass times acceleration. So for you to get the derived unit, see, this thing is sounding very funny and very she gravity, she and wine, it's in the spot we did. Check your past question. They will follow you around with simple questions. They'll tell you that which of the following has the same derived unit as this. And you'll be thinking, you'll be racking your brain, you don't know what to do. Because you don't understand the simple steps, all the simple things. And you feel that you know. You don't know it. Pay attention. Now, how do you get the unit of force now? From the formula, mass times acceleration. Okay, the unit of mass, I gave you already, to be what? To be kilogram. So this is kg times the unit of acceleration now. Okay, I've not given you that one. Okay, let me come here. Acceleration here is the formula, in case you don't know, is velocity over time. Okay, so let's see the unit. The unit of velocity. We don't know that one again. Okay, let's come down here. The speed. Now, speed and velocity are like the same thing, but just that one is what? Scalar. The other one is what? Vector. Speed is scalar. Velocity is vector. Hey, don't gonna say because of S for speed, scalar. V for velocity, vector. No, that's not why. Velocity deals with direction. So they don't deal with direction, okay? So speed is simply distance over what? Time. So we can get the unit of this one. Distance. Distance means the gap between one point and one point, which means length. So distance is still the same thing as length, and length is in what? Meters, n, over time. Time can be in seconds, can be in hours, can be in centuries. But what do we use in science to do seconds? So this is m over s. So we say meter per seconds, like this, m/s, or m/s raised per minus 1. I believe everybody knows indices and all those rubbish we did that time. So let's bring it back here now. What is the unit of velocity now? We just got it now. What do we get? Meter per second. That's m raised per minus 1, isn't it? Yeah. Over time is what? Seconds. That's s raised per 1. If we do our maths, there's not enough space on the board. This place show you this part.
Where?
Okay. If we do our maths, let's bring this down here. We have m(s) raised per minus 1, isn't it? Then what's this? Divided by s raised per 1. If you remember indices, when you have the same base, what do? You pick one. If there is division between them, you subtract. If there is times, you add. So what do you have in between them? Division, Abi. So that means you subtract the powers. Let's go. M(s) raised per minus 1 minus 1. That will give me m(s) raised per minus what? 2. So the unit of acceleration is m(s) raised per minus 2. We can call this meter per second square. Clear? That's for acceleration. Now let's bring it back into force. Now we're dealing with force first before we now came to acceleration. Force is mass and acceleration. So the mass is kilogram times acceleration is what? Meter per second square. So let's put it here. Meter per second square. I multiply kg times m(s) raised per minus 2. What's it going to give me? Kg m(s) raised per minus 2. So we call this kilogram meter per second square. Some of you here don't know that the unit of force is this. I believe some of you here don't know that the unit of force is this. You only know that it's Newton. You only know Newton. But this is also a unit of force. They can tell you that one of these is, they just give you this. The unit of force is dash. You are looking for Newton. You don't see Newton. What you are saying there is kilogram meter per second square. That's why it is called a derived unit. We are deriving the units. Now, in physics, we don't really use these units because, like I said, quantities have various units, but only one is sometimes 1 or 2 is the generally accepted one, which we call the standard international unit. So when gravity and some scientists came together, who is doing this like this? Came together, they are saying that okay, let us change this. This is not looking fine. Let us use a different unit. Now called the unit what? Newton. In respect to the scientist Isaac Newton, the person that talked about Newtonian physics and all that, force and all this blah 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 blah. Are you getting that? So the unit of force is simply what? Newton. Please, when you're writing Newton, don't write N like this. Like this, N. The man is not your mate. He was born in 1642. That time you were not even thought of to be born. Even your dad himself. I don't know. So what do you write now? You write this as what? As big N. Like this. Capital letter N. So that is the unit for force. Let's go straight to surface tension. Who knows the unit of surface tension here? Okay. Surface tension is actually what? What's the formula of surface tension? Force over length. Force over length. Have you written this part? for speed. I want to rub it up, so there'll be space. So the unit of the formula for surface area and surface tension is simply force over length. So let's see the unit, derived unit. So let's go. Anybody that is sleeping beside you, help their life. Your life literally depends on this. Okay? Yes. Imagine you live, God forbid, let me not say it. Force over length. What's the unit of force? No. What you just got? What's the unit of force? K G M S raised by minus 2. Abi? Over. What's the unit of length? Meter, isn't it? If I divide, this can cancel out this. So what do you have now? Kilogram per second square. Are you getting that now? Although the one you may know is Newton per meter. Okay? But the unit of surface tension is also what? Kilogram per second square. Is this clear or clear? Is this clear, class? It's clear. So some quantities may have more than one unit. Are you getting that? More than one unit. But let us use the other units we know. One unit of force is what? Force is Newton, Abi. So if you use that unit, force is Newton over length is what? Meter. That will give me Newton per meter. This is also a unit of what? Of surface tension. So out of these two, the one that is very, very acceptable is what? Is this one, Newton per meter. This is what we use when we do your calculations. We don't really use this one, but this is also a derived unit of surface tension. Clear or clear? Clear. The next one we have is density. Density. What's density? What's density? Mass over volume. That's mathematical definition of the density. Mass over volume. So let's go. Mass is what? Kilogram. Isn't it? Yeah? Over. What about volume? Volume means length times breadth times height. That's meter times meter times meter. That will give me meter raised to 3. So the unit of density is simply kilogram meter cube. That's kg m raised by minus 3. So this is the unit for density. Although density also have other units. It has gram per centimeter cube. Look at this, it's kind of the same. But this one is just in kilograms, this one is in centimeter cube. You get. This is also a unit of what? Of density. But the most acceptable here is what? Is kilogram per meter cube. Is this clear or clear? Now let's try one. I'll give you one to try, then we'll move straight to dimensions. Let's try one. I can have this off. Let's try one. What is the unit? What is the unit? Right. What is the unit of the universal gravitational constant? Yes? The symbol for that is big G. Big G. Shall I give you the formula? Okay, the formula is, do you remember, have you ever heard of the law of universal gravitation? Who gave that law? Who gave that law? Gravity. You don't have respect. Isaac Newton. Where is Sir? Sir what? Isaac Newton. Okay? In his famous law, the law is called the law of universal gravitation. Now it's talking about the gravitational force between two bodies. For example, now between me and this board now, there's a force between us. That force is called the gravitational force. So Isaac Newton was able to tell us how to calculate that gravitational force. So mathematically, we say that force is equals to G m1, that's the first mass, times the second mass, divided by the square of the distance. So this G here is called universal gravitational constant. So find the unit for me in 2 minutes.
That's so much. There were 6 before, now there are 10.
10. Okay. Can I continue? What's the answer? What is your answer? Kilogram, meter, whatever. Now, your force must be in Newton. Okay, Newton, because Newton is the most acceptable unit, the SI unit for force. Okay, let's go. I'm looking for G, Abi. So let's go class. So when you cross, what are you going to have? G M1 M2 equals to F R squared, isn't it? So if you divide both sides by M1 M2, divide both sides by M1 M2, my G will be equals to F R squared over M1 M2. Yes or yes? Okay, let's go. What's the unit of F? F is not far without. F is what? Force. So this is giving me Newton. What's our distance? Our distance is meter, Abi. So this will give me meter squared over, what is our M? Our M is not meter, our M is mass. What unit of mass? Kilogram. Kilogram times kilogram give me kilogram squared. So we can write G as, we say this is Newton meter square per kilogram square. So this is the unit. This is the unit for what? For gravitational field, universal gravitational constant. So let's see a question from your past question. Past question. Is it me? Yes. Okay. Let's go. The question says, are we ready?
Yes.
It said the units, we are going to solve 5 questions from this part. Then we move. The units, let's go. The units kgm SS power minus 1, that's kilogram meter per second, that's kgm SS power minus 1, is the same as the units kgm SS power minus 1 is the same as what? A. It's the same as A. Newton seconds. B. Newton per seconds. C. Per Newton per seconds, and D per Newton seconds. 5 seconds. 1. What's the answer? A, D, C. Someone say G. G is not in the option. Yes, what's the answer? You. What's the answer? This brother. Yeah, no. A is the answer. Yeah. Okay. What's the answer, mommy? You. Fine girl. You know. You're the fine girl there. What's the answer? A. How about you now? Yes, you. B. I like the controversy. Different answers. What's your answer? You on yellow. You on yellow. You. B. Tell me, what's the answer? What's the answer? You see. As simple as this thing is, you see they think, what's the answer? A, B, C, pick up the options, A, B, C, D, E, F, U. Yeah, no, how do you do this? They said this unit is the same as which of them here? They're trying to ask you. If a very simple way to do this is by solving the options and changing them to this one. Now Newton, talking about force. And force is also what? Kilogram meter per second square, if you remember. Because force is what? Mass. See, don't forget. Force is mass. Is MA, Abi?
Yes.
And M is what? Kg. And A is what? MS per minus 2, isn't it?
Yes.
But since we are looking for this, and all the options, they are in Newton. Now, what they wanted to do is to express Newton as kilogram meter per second square. You see that now? You can see why you need to know other derived units of every quantity. So we know that force, this Newton here, is the same as what? Kg MS per minus 2. So let's now put this into the options and solve. Are we getting that? Looking at this one, it looks quite off. It looks quite off now. This one looks quite maybe close. So let's try this one first. Option A says what? NS, isn't it? And what's N? N is force, and what is force? Kgm ss power minus 2, isn't it? Then times what? Times s, ss power 1. That will give me Kgm ss power minus 2 plus 1, isn't it? Why is it plus 1? Because of this is times. This is going to give me Kgm ss power minus 2 plus 1 will give me minus 1. Is that the answer? So it doesn't make sense for you to start trying this one, because you can see this one looks quite off. This one too looks quite off. It's either this one or this one. Do you understand? So what's our answer here? A is our answer. Number 2. He said, which of the following is not a complete set of SI units? Which of the following is not a complete set of F of SI units? Not a complete set. Which of the following is not a complete set of F of SI units? A. Meter, second, ampere. B. Meter, kilogram, meter, kilogram, seconds. C. Meter, Newton, kilogram. And D. Meter, kilogram, ampere. Listen to the question. He says what? They didn't ask you for fundamental unit though. What they asked you? It's not. Which of them is not what? It's not a complete set of what? SI, not see. This is where students will fail it. Because all your mind is that complete set of fundamental.
Yes.
If you understand. You want to think that okay, which is not a complete set of fundamental. Okay, I asked someone said Newton.
C.
Someone said C now. Because you saw Newton, you said Newton is not a fundamental unit. And that's almost of 90% of you will pick. You not read the question very well. This one is part of it because everything here, they are all what? This is SI unit now. Meter is SI unit. SI unit. SI unit. You understand? So which of them is not? So this one is out of the answer. Let's look at option A. Meter, second, ampere. They are all SI units. This one is also what? Out. Yeah, let's see.
All of them are.
Okay. The same which one of them is what is the question again? What is the question?
Which of the following is not a complete set of SI units?
Is there a complete set of SI units? She have not missed one word. Second. Okay, if I'm to pick a question, an answer here. Meter, kilogram, ampere. I'll still pick this one out. Okay. Let's go again. Because everything looks like the obvious answer.
Yeah,
but one of them is still. Now when I did English language in JAM, they say which of them is nearest to the meaning. Everything is the meaning. Is the synonym. Is this an antonym? I don't think English is that synonym. But one of them is the best, isn't it? So the same way. So let's do that same thing here. Meter, kilogram, ampere. This is SI unit. This is SI unit. This is SI unit. Let's remove this one out. Meter, seconds. In short, when I have meter is SI unit. So that one is there already. Seconds is also what SI unit. So anyone have seconds, let's cancel it out. This one is out. Seconds, ampere. Abi? Because ampere is also SI unit, isn't it? Let's look at option B and option C. Meter, kilogram, seconds. Meter, kilogram, seconds. Meter, kilogram, seconds. Meter is SI unit. Kilogram, yes. SI unit of what? Mass. Abi? This one for time, out. So if I'm to pick anyone, actually I'll pick what? C. Although this is also SI unit, which means that the question is
Not direct. And the options.
maybe what they meant
It's fundamental.
was actually fundamental units, not SI units. So when you're answering a question, there's one thing about you knowing the answer, and one thing about you being smart and what to choose. And you know what I do now? I did elimination method. Yes, that's what you do. If you don't know the answer, you can eliminate. Like this one cannot be the answer. This one cannot be the no, this one is obviously wrong. Do you understand? Then the last one standing is your answer. That's the way to get an answer when you don't know the real answer. So the answer here is what you see. Let's solve one more. Let's solve one more. The watt is equivalent to dash. The watt is equivalent to dash. The watt.
Use this
Okay. The watt is equivalent to dash. That means what is the watt equivalent to? You know what they call watt? Watt is a unit for what quantity? Power. Equivalent to dash. A. We have Newton meter per second. B.
Yes.
We have joule seconds. Joule seconds. C. We have kilogram meter square second square. And D. We have Newton per seconds. So they say it's equivalent to which one of them? Now, let's solve it together. Let's solve it together. Watt is the unit for what? Power. And power is how fast you do work. It means it's work over time. Now, work on its own. Work on its own is force times distance. Force times distance. Let's get the unit of work, shall we? Force is what? Is Newton.
meter.
Distance is what? Meter. That means the unit for work is Newton meter. Are you following? Other unit for work, let's see other unit for work. Force is also what? Force is also what? kg meter per second square. Abi? Times distance is also meter. That will give me kg meter square per second square. Are we getting that? So work has two units here. It has Newton meter and it has what? It has a kilogram meter square per second square. Which of them is the most accepted?
Both
One that one of the SI unit here is the SI unit is not here. The SI unit is what? Is joules. Okay? So the SI unit of work, SI unit is joules. So we're having three units now. We're having this and that. So let's try every one of them. But let's see the options. Okay, I'm saying joule here. So let's try joule first. Are we getting that? Let's go. The unit of work is what? Joule. Are you following? Over time is what? Seconds. That will give me joule per second. Out. Are you with me? Let's try Newton. Let's try Newton. Let's go. Work is what? Newton meter. Are you following? Over time is what? Seconds. That will give me Newton meter per second. Okay? Yeah. Newton meter per second. So that means that this is the answer. Is this clear?
Yeah.
Is this clear? Right. Dimension. Dimensions. If anybody is sleeping beside you, you find that here that say you don't have bed in the house. Just whisper like softly. Don't shout. Don't let him wake up. Just whisper like softly. But there's bed in the house now. You left your house, man. Suffer mosquito, and you are sleeping. What is the color of your problem? Is it blue or black or purple? Tell them you are here. Okay, I should snap them. You snap them here now. Let's go. Dimension. Can I have this up?
Yes.
Dimension. I'll be fast. Dimension. Oh, those things I wrote here. You wrote it down.
Yes.
Okay, good. I want to know how we are going. Dimension. Dimension. Fast and simple. Dimension. Shows relationship between derived quantity and fundamental quantity. So what relates them is called what? Dimension. Are you getting that? So dimension shows what? Relationship between derived quantities and fundamental quantities. Yeah, see, all those your fundamental quantities, they have dimensions. Okay. So now, for now, we deal with only three fundamental quantities. What are they?
Mass.
Everybody knows this now. Mass, length, and what? Time. Now, each of these things, are they dimensions? Dimensions.
No.
Wait, let's go again. Let's go. Someone say yes now. Mass, length, and time. Are they, what do you call these three things? What do you call these three things? They dimensions? Quantities. They are what? Quantities, not dimensions. What about this one? kg, meter, seconds. What are these ones? Thank you. You have to understand the difference between dimension, unit, and quantities. Now, what about this one? M, L, and T. What are these ones? They are dimensions. So this is just showing us the relationship between the derived quantity mass and a different quantity, or maybe the fundamental quantity mass and a derived quantity entirely. Are we getting that? Please, you can say I wrote my own M. Let us not be mad in Jesus' name. The M is not like this. Okay, this is wrong. This is meter. The M must be gallons, capital letter M. The L2 and the T as well must be gallons. Are we together? Good. So now, note something. Not only fundamental quantities have unity, not only fundamental quantities. Okay? Derived quantities also have what? Dimension. Not only fundamental quantities have dimension. They also have what? Dimension. How can we get a dimension? You can get a dimension by deriving the dimension. For example,
So batch. No batch.
okay. Right, power bank. For example, now, let's see velocity. Velocity is displacement over time. So what will be the dimension? Let's see. What will be the dimension? What will be the dimension?
Don't risk it.
There is my code. Who has iPhone code?
You have to shift it like this. Shift it to this side.
So you can see the down part.
Is that what I said? I didn't even check. Yeah, it's okay. I think she move it back. It's bent. It did. See you soon.
Okay. All right. Displacement over what? Time. Displacement means distance. Same thing, but in a specific direction. Are we getting that? So that means that distance is also length. So what's dimension? L. Over dimension for time is what? T. That will give me L to this one. Clear or clear? Everybody knows this one. Very simple. Showing yourself, Abby. I'm getting somewhere. Let us see acceleration. Acceleration is velocity over what? Time. Isn't it? What do you get as velocity? Lt raised by minus 1 over t. When I say over t, I mean Lt raised by minus 1 divided by t. Isn't it? It's the same thing now. Isn't it? So indices now, you want to have the same base. So Lt raised by minus 1 minus 1. That will give me Lt raised by minus 2. So this is the dimension for what? For acceleration. What is this telling us? This thing is telling us the relationship between acceleration and the fundamental quantities, length and time. It's showing us the relationship between them, how they are related. Are we getting that? It's not a very, very simple one now. So let's try one more. Let's try density. Density is simply what, class? Mass over volume. What is the dimension for mass? Kilogram, Abi? Kilogram. M. Over what's the dimension for volume?
L raised by
Thank you. L raised by 3. That will give me M raised by minus 3. Clear or clear? Clear, Abi. This one is simple, Abi. It's simple, Abi.
Yes,
It's simple.
do this
Yeah,
close.
let's do this one. Okay. I'll explain again. Let's see this one. Right. What is the dimension? What is the dimension of
Power,
what's it called?
pressure.
Okay, talk. Let's talk. Okay, let's say talk.
First time this stuff.
What is the dimension for talk? Everybody, yeah.
Okay.
Everybody.
It's okay now.
Okay. Share, if you have not shared the new,
ML squared is equal
if you have not shared
ML squared is
wait,
equal minus.
you have not shared the new YouTube link, you're a donkey. So if you want to be a donkey, go to your WhatsApp now. It will not take you anything. It will not even take you anything to share. Click and share. Anytime you have anybody to share. Now there will be 100 level students in your contacts. You can't tell me that. You can't tell me that there is 100 level students that you know. It's not possible. So share it on your status. Okay, I shouldn't be taking to share on your status. Share it on your, if I say you should pay for this class now, it's a different thing. It's free. So share it on your status. Share it to one or two persons that you know that, okay, might need the class. Share it to them. Alright. So let's go. Talk. Talk is the force that causes what? Rotation. Okay? So talk is moment. And mathematically, torque is the vector product of what and what? Of force and distance. Don't mind my arrow. We are going to scale and vectors very soon, so you get what all those things represent. So when you multiply force and distance, you get what? Torque. So let's see the dimension. Let's go. Dimension for force. Don't forget, what's the formula for force? Let's do that somewhere. Force is MA. N, the dimension of mass is kilogram. It's capital letter what? N. And dimension for acceleration, just solve that now. It's LT raised power minus 2. That will give me what? LT raised power minus 2. This is for force. So I can carry this thing now. See, and carry it and bring it here. Okay? So what's it going to be now? What's force? LT raised power minus 2 times distance is length. So that means it's still what? L. So this L raised power 1, this L raised power 1. That will give me what? ML raised power 2, T raised power minus 2. Is this clear? So that's the dimension for torque. Simple, Abi? Simple, right? But yeah. What is the dimension for the universal gravitational constant G? That G I gave you just now. That's in G. From that formula I gave you, F equals to G M1 M2 over R squared. Yeah, everybody, find the dimension for G for me. The dimension for G. The dimension for G. What's the answer?
M is by minus 1, L cubed, T is by minus 2.
That was fast. Only 5.0 people. See them. See them everywhere. Okay, can we solve together now?
Yes.
See, one thing that will make you pass your exam is speed. Not that you know it. Speed is the most important thing.
Seems on.
On it. Don't go and do Asheju and speed. Because I say speed now, you now solve rubbish very fast. You solve rubbish very fast. Not that too. There's the power button. You now solve rubbish. Press this. You now solve rubbish very fast. No, that's what I mean. I mean speed and accuracy. Okay? So let's do it together. G is equals to F R squared over M1 M2. Yes or yes? Yes. So let's go. What's the dimension for force? We just got it now. MLT raised power minus 2 times Distance is L. That's L raised power what? 2. Over mass is M. L gives me M raised power what? 2. So what will G be equals to? It's going to be equals to M. L times L raised power 2 give me L raised power 3, isn't it? Then T raised power minus 2 over M raised power 2. Are you following? Yeah. So what is it going to give me now? It's going to give me G equals to, this is M raised power 1. Okay? And this is divided by M raised power 2. That will give me M raised power 1 minus 2. That will give me M raised power what? Minus 1. Do you understand that? Then L raised power T. L raised power 3. T raised power minus 2. So this is dimension for what? Universal gravitational constant. Listen, given that the dimension of the universal gravitational constant G, given that the dimension of the universal gravitational constant G is m raised by x, L raised by y, and T raised by z. Given that what dimension you need it, you know it today.
Very easy.
Very simple. You think you need it. Just control your mind that you need it. So now answer is even clear. Given that the dimension of the, what am I saying? Leave that word y is what? M raised by x, L raised by y, and T raised by z. Find the values of x, y, and z. Are we together?
Yeah.
They said this thing. What they said in that question now, they said this thing. Yeah? This thing you are seeing here is the dimension for who?
Gravitational
For G.
constant.
Yeah.
Abi? This thing is G. Do you understand the math now? So this thing you are seeing here is the dimension for G. And when we solve, what do we get for G? We got this. That means I can equate this and equate this, isn't it? Since this is this. So I can say that what? M raised by x, L raised by y, and T raised by z is equals to what? M raised by minus 1, L raised by 3, and T raised by minus 1. Are we getting that? Now I am equating two dimensions. We call this dimensional analysis or dimensional equation. So you can have equations in dimension. When you have equations, you call it dimensional equation or dimensional what? Analysis. Now if you compare the exponent, I'm speaking English, if you compare the powers
Yes.
of each of the dimension, compare the powers, whatever you get is your answer. See, look at this. You have M here, you have M here. What's M carrying here? X. What's M carrying here? Minus 1. Compare the powers. That means I can say that what? X is what? Minus 1. If you compare the powers of M, are we getting that? Compare the powers of L. What will be Y?
3.
Y will be what? 3. Compare the powers of T. What will be Z? Z will be minus 2. Do you understand that? That is it. It's very simple. So if they give you a question on dimensional analysis, you should be happy. Because you just compare dimension of this one and the left hand side, you get your X, Y, and Z, whatever they give to you. Are we together? What do you call this concept? We call this dimensional equation, dimensional analysis. The other part, but this is one that Unilag will give you. Do you understand? Let's take one example. One example that I move. The period of oscillation, the period of oscillation, the period of oscillation, the period of oscillation of a simple pendulum, the period of oscillation of a simple pendulum. I need a new plate to form the board. This is making the board dirty. This part of the hair is too long. Yeah, cut it.
It cannot create it's okay
No one has.
Alright, the question says, where are we? Of a pendulum is defined. You don't know somebody's auntie.
This one.
Is defined as is defined as t equals to k m raised by x l raised by y
Okay. Sit there.
Gravity, are you doing chemistry?
raised by z. Where k is a constant. Where k is a constant. Find the value of x, y, and z.
Is it class what?
Yes, yes. Find the value of what? X, y, and z. Find the value of x, y, and z. What's the answer? Abi?
Got in what?
I know.
Funny, I've forgotten it.
What is the question again?
They said this if t is a period. This t is period.
That is the value.
This t is period. Okay. This k is just a constant. Does not have a dimension. Are you getting that? This m obviously dimension of mass.
Okay, M is
This
mass.
L, yes, dimension of length. And this g, you know what g is, Abi? What's g?
Gravity.
Not gravity per se. Calm down. Acceleration due to gravity.
Okay.
So solve now. Should I solve it first?
No.
Yes, that's what we did.
Yes.
Don't solve it. Let them try it.
Remember it.
I was not
I
even.
need to math.
I need to
No, you give me
record.
blow. Hey, let's do it. No, let's do this now. I'll give you tougher one. Add that one. I'll give you like other than this one. Oh yeah, let's go. What you just do, write the dimension of each of them. Dimension of each of them, each of the quantities. What's the dimension of tension of is this tension?
Period.
Period. So period is still t.
Just power.
Do you get?
Minus 1.
Period is time. Abi? And time, what's the dimension of time? Is still what? T. If this was v, like this, what would be the dimension? L t raised by minus 1. Do you understand? Because v represents what? Velocity. So you have to write the period. You have to write the dimension of each of the quantities you are seeing in that your equation. Do you understand? What's t represent in class?
T.
Tambolo. What's t? What's t?
Period.
Period. And what's period? Time. Abi? So this t is still t. What's k? Does not have a dimension.
Yeah.
Let's leave it.
It's 1.
Let's leave it. Let's just leave that as 1. What's m? M is still m because it's mass. Are you getting that? What's L? L is still length.
Yes.
So we leave that as that. But what's G? G
L.
is not G. Is G part of our dimensions?
LT.
G is acceleration due to gravity. Abi? That's acceleration. Are you getting that? And what's the dimension for acceleration? What's the dimension for acceleration?
L is my minus.
Thank you. So this G is what? LT raised by minus 2. All raised by what? Z. Are you getting that? See now, this is G now. Are you following?
Yeah.
All raised by Z. So let's open the bra. Give me M raised by X, L raised by Y. Z you multiply the powers of L and T. Abi? What's the power of L here before? 1. Yeah, 1 times Z. L raised by Z. Are you following? What about this one? So give me Z raised by minus
2Z.
Z. Are we getting that? So what do we simply do? We can see these two. We can multiply them now.
Y plus Z.
So let's go. T equals to M raised by X. Abi? This
L-
one will give me L raised by
L-
Y
Y
plus
plus
L
Z.
raised by Z. That will give me what? L raised by
Y
Y
plus Z.
plus Z. Isn't it?
Simultaneous.
Then T raised by minus 2Z. Now, when you now get to this point, what do? You
Compare.
compare the exponents of the power of the right hand side and the left hand side. Okay? Do we have M in this side?
No.
No. That means what's the power of M? 0. What I can do is I can write this T as M raised by 0, L raised by 0, and T at T raised by 1 equals to M raised by X, L raised by Y plus Z, and T raised by minus 2Z. Are we following?
Yeah.
You know, now this is the same thing as T.
See 1
M
1.
raised by 0 is T1. L raised by 0 is T1. Do you understand what I'm saying? So if you compare now, let's compare.
Yes, yes.
Let's compare M raised by X to M raised by 0. What's our X?
0.
What's our X?
0.
1.
0.
What's our X? You know. This M raised by 0. Compare M to M now. M raised by 0 equals M raised by X. Abi? So that means that X is what?
0.
So x is 0. Are you getting that? A raised power 0 equals a raised power y plus z. So that means that y plus z equals 0. Are you following? The power now of y is equals to 0. Do you understand that? So I can do my math. I can say I do this one here.
Find
Let's
Z.
say y equals to minus z. Have you?
Yes.
Do I know y?
Find Z.
Do I know z? No. Let us pen this one as equation 1. The next one, yeah, for t now, what are the powers? Minus 2z, isn't it? Equals what? 1. So I can say minus 2z equals 1. I can find z from here. Divide both side by minus 2. So my z will be equals to minus 1 over 2. Now that I know what z is, I can find my what? Y. From equation 1, what is my y? Y is minus z. So y is minus, what's my z?
1 over 2.
Minus 1 over 2. So y is equals to 1 over 2. So therefore, I can say x is 0, y is 1 over 2, and z is minus 1 over 2. Is this clear, okay? Is this simple? Is this simple?
Yes.
Yeah, let me not give you that one. That one you not solve it by yourself. Yeah, right.
Just simple. Don't give up in life.
There's too much talk here. I don't want to start reading the entire word. They said it is found that the proportional force of the drag force of the blah 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 tends to blah 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 blah. The question is, okay, I see right.
Yes.
Yeah, jump faster, jump faster. Jump faster. I'm very sure what's time. I'm very sure once it's 2, then you start to snooze. Okay, from that side. You snooze, you lose. You snooze, you lose. I've been coming here for the past how many days now? Consecutively. That missing a day. Yesterday, we had class yesterday now. And I came, in class. I came for night that morning, that's and I came for class in the morning. After that class, I'm here again. And tomorrow morning, I still have class with you guys.
What in the morning?
You don't know.
He said no. Let me look for any of you in class. Only for you. Only for you in class. Don't worry. Alright, can we go now? Okay.
Go for beach.
Hello.
I like to tell of this.
So this is the question. The question goes like this. It says that f is equals to k is power 2 x and a raised power z. Okay? Okay?
Yes, sir.
Yeah. Yeah. F is force. I just say drag force, how they say there. But it means force. Okay?
Yes, sir.
This, you can tell me what this symbol means.
Physics.
Momentum. Density.
I'm disappointed. The symbol is rho. That's the name of the Greek symbol, rho.
We call it F, what do you call it? Broke.
We call it rho. What's the name of this symbol? What's the name of this symbol? Aquaman fork. What's the name of this symbol? Aquaman fork, Abi. In physics, this is a wave function. This is a wave function. This will determine the probability of finding an electron in an electron cloud. The probability of finding an electron in an atom is determined by the square of this. The square of this function. The function is called psi. 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 How about this one?
Lambda.
Lambda. That's wavelength. Abi. What about this one?
I don't know. Gone.
Upside down. Triangle.
Triangle upside down.
Upside down triangle.
Alright, velocity. V is velocity.
Obviously.
And A is what?
Area.
Yeah, play with that for me. Find x, y, z.
Okay, sir.
The
First.
first one to get it,
Yeah, now. K is constant.
I'll give you 500 naira.
Okay, sir.
Here's my money. Here's my. I don't have cash, but I'll do transfer. I'll do transfer. First one to get it on both online and online. If someone gets it online first, I'll give the person. Okay. So both online and physical. First one to get it 500 naira
L.
for you. Down and buy card. Says.
Calm down, Joe.
S is 1/2.
Wait now.
Okay, you're the first. Yeah.
Is it correct?
Let me hear
You
it
should
first.
do everything now. Which
It's the
one?
first person.
S is 1/2.
Are you talking about
X is 1/2.
1/2?
Y.
Is 1.
1?
Z is 1.
What did you get? The same thing.
No. Y is -1.
Okay, it's first person. Second person.
Y is -1.
Y is mine. Okay, that's the difference. X is 1/2.
Why?
Y is -1, and Z is what?
Yes, why is my.
Z is what?
No, I'm on Z. I'm on Z.
Okay, you're not done now. Who is done? What do you want?
Just a second.
X is 1/2.
Second person. X is 1/2.
Y is 1.
Y is 1.
Z is 1.
Okay, at the same time, that means it's still leading. The same thing as in, that means it's still the first person. I want a different answer.
Different answer.
Yes. The same thing.
Can't be too wait.
You get it. Your own Z is unique.
Just
You
a
used to
minute.
have unique answers.
Plus Y is.
Okay, Gravity.
Yes.
Okay, X
Gravity. X is 1/2.
Who
Y
is
is 1.
talking?
Z is 1.
X is 1/2.
Y is 1.
Z is 1.
Yes.
It's still leading you then.
It's
It's
not
still
about
the first person.
which one boy you said? I will send you message.
Okay.
That's the correct answer.
I think that's the correct answer. So let's solve it together, shall we? So let's go. So please remember, let me write it down here.
Okay, sorry. D.
Oh, yes, it's a big.
It's 2Y.
I'm writing something different.
Your density.
And this is ML.
Alright, let's solve it together. Some of you are not even attempting. If you're not attempting, you sleep. So, when you solve and you're sweating, that's when you lose sleep. Go together. Now, after this one, we move straight to what's the next topic that I wrote on the board? What's the next one I wrote on the board? What's the next topic now? Scalar and vector. Alright, so let's go. Yeah, I said the first, what you have to do in dimensional analysis, oh, simple, it's simple. Just do what? Write the dimension of each of the quantities. Okay? Write dimension of what? Of each of the quantities. Write the dimension. And let's go. Dimension for force is what?
LT. ML raised by minus 2.
LT raised by minus 2. Is this clear?
Yes.
Equals dimension of K. K is dimensionless, so 1. Let's leave that out. Dimension for, what's this thing?
Density.
Density is
M
mass over
L
volume.
is minus 3.
What will be density? Mass over volume. So what will be the dimension? This is M. What's volume? A raised by K. That will give me M L raised by minus 3. Is this clear?
Minus 2.
Is this clear, class? So what's density, class? M L raised by minus 3. All raised by what, class? Are we here? All raised by what? 2x. Do you understand? Talk to me now.
Yes.
Okay. Times, what's the next thing?
Velocity. LT raised by minus 1.
LT raised by.
I got an answer.
Other answer, okay, give it to me.
Y is 1. I don't
X
get
is
that.
what? X
Like the
is
three of them, 1, 1, 1.
No.
1. X is 1, Y is 1, Z is 1. No problem.
Never.
So if your own is correct, that means that you're the one that is doing it. So let's go.
Share the money.
Oh yeah, now let's go now. Velocity is what, class? What's velocity?
LT raised by minus 1.
Yeah, let's go. LT raised by minus 1. All raised by what? All raised by what? 2y. And what's the last one? A. A means what?
L square.
A is diameter.
L square Z.
Area is length times length, or whatever. That's L square. So that will be times L raised by what? 2. All raised by what, class?
Z.
Now it's getting too much. All raised by Z. Give me an answer. So let's go. So give me M, L t raised by minus 2. That's for this side. Then this exponent will open the bracket, Abby.
Yeah.
All this one have now. Some have
M2s.
n equal to
2s.
m raised by 2x, Abby.
Yeah.
Some become
L is
by
minus
minus
6s.
6x. Are you following? Now I got 6x, Abby. Multiply. Times this one called L raised power
2y.
2y.
T raised by minus 2y.
And t raised by
Minus
minus 2y.
2y.
Are you following?
That's where my mistake
That's for this part. This one we call
L
L raised by what?
2z.
Z. Who is lost at this step? Who is lost at that step? You are pressing your phone. You're telling me you are lost. You're raising your, you're pressing your phone, chatting. You're raising your hand and you're lost. What part? On here, Abby? Use your eyes and go through it. Yeah? You know I got this part.
Yes, I know.
You know I got this part.
Yes,
You know I got this part here. Okay, so from here, this 2x, we will multiply the exponent of each of the bases. This m raised power 1. 1 times 2x give me m raised power 2x. This m raised power minus 3. Minus 3 times 2x will give me m raised power L raised power minus 6x. This is L raised power 1. 1 times 2y, L raised power 2y. This is t raised power minus 1. T raised power minus 1 times 2y will give me t raised power minus 2y. Do you understand that? This is L raised power 2. 2 times z will give me 2z. That's L raised power 2z. Now, we can now bring the one that have the same base, bring them together. So let's go. Let's go. This will be m lt raised power minus 2 equals to, we only have only one m.
Yeah.
M raised power 2z. We have plenty L. Yeah. This is L raised power minus 6x
Plus 2y.
plus 2y plus
Yeah, plus 2z.
then plus 2z. Who is lost? Who is lost? This, and this.
Multiplication.
What do you have left?
C is power
Raised
minus.
power minus 2y. Are you following?
Yep.
Now what do you now do from here? You compare exponents. Exponent of the right hand side and left hand side. Let's go. What's the exponent here? This is m raised power 2x. This is m raised power what?
1.
1. Eh? This m raised power 2x. This is m raised power 1. That means that 2x is equals to what? 1. Look up. Oh.
They are solved it here.
So 2x is equals to what? 1. So what will my x? X will be what? Divide both sides by 2. 1 over. That means that person that gave us that one is wrong. Who is the person? Okay, Adadi is wrong. So Tijani, let's Tijani.
Yeah, you 50-50.
Is looking. Tijani is answer is looking correct already. X is 1 over 2. Do you understand how we solve that? Let's now find y.
It's 1 1.
Okay, before we find y, this one, this L is power. This one's having plenty.
It's
plenty
y
instances.
first.
Let's do this one first.
Y.
That's having sense. So do this one. So we don't have we don't have y and z. Let's do this one first. Do you understand? So this one, what's the exponent here? Minus 2y is equals to what here? Is equals to what here?
Minus 2.
Minus 2. That means minus 2y is equals to minus 2. Break it down, divide both sides. This cancel that. So you
Y
have
is
y
1.
equals what? 1. Okay, Tijani Alpha. Look as if you talk back in the
Size me and
It's
him.
not yet.
Let's see the last one. The last one is the power of n. Yeah, what's the power of n class? Minus 6x plus 2y plus 2z. Everything is equals to what?
1.
So we know what x is. So this is minus 6. What's x?
1
1
over
over 2. Plus 2. What's y?
1.
1. And plus 2z equals to 1. So break this down. So give me minus 3. Abi?
Plus 2.
Plus 2 plus 2z equals to 1. My 2 and my z is looking almost the same thing. 2z. Okay? So minus 3 plus 2
Minus
will
1.
give me minus 1 plus 2z equals to 1. So
Z
bring
is-
collect
Z
similar
is-
terms.
Z is
So 2z will be equals to 1 plus 1. That will give me what? 2. So divide both sides by 2. Our z is equals to 1. So that means, so therefore, x is 1 over 2, y is 1, and z is what? 1. Let's clap for Tijani now.
Someone here. Someone got it.
Someone got it.
This one means Fatima.
Okay, when did she? So somebody first here now.
Somebody first thing.
Yeah, somebody got the answer online. But
Before we
no, this guy.
Danny
This guy was the first person.
For me, so I tried now.
Before anyone there. He was the
Somebody
first person.
told me that tried.
Please be fast. That's the meeting. So, some of you are just looking. Hey, myself. Attempt solve.
I think I just learned this stuff. So
Just learn it, Abi.
Imagine
Let's go scalar and vectors.
Not this with my life.
I swear my life.
Scalar and vectors. Scalar and vectors. They are very, very sharp. Scalars, they have only magnitude. Vectors, they have both magnitude and direction. Which means that if you are representing a vector, you represent a vector using both magnitude and direction. I told you guys that when you see a vector, how do you know it's a vector? You will see a letter and you see an arrow. Okay? The letter represents the magnitude of the vector. Are you getting that? Why the arrow represents that that vector has a direction. If I give something like this, I give you two quantities.
Hey.
That's it right here. That's in this place. At the top. You're not here. So people like you, they will give you S point right. You still be writing one by one.
I still not done the same.
See, if I give you two vectors, two quantities, quantity A and quantity B, what can you say about these two quantities? Because this quantity only has a letter. So letters represent magnitude. So since one only have only magnitude, so is what? Scalar. But this one has both magnitude and it also have an arrow. The arrow represents direction. So that means that this one is what? Vector. So B is a vector and A is a what? Is a scalar. You now want to ask you that which of the following is not a vector. So you have to know at least five scalar, the popular ones. Okay? Okay, let us look at mass. Mass is what? Scalar or vector? Scalar. Scalar. Length.
Scalar.
Time.
Scalar.
Temperature.
Scalar.
Scalar.
Density.
Density.
No.
Scalar.
Scalar is actually scalar.
Okay, I'm giving you a minute, that's 5 now. Have you? Speed.
Scalar.
Distance.
Scalar.
Walk.
No.
Walk. It's scalar. Power. Scalar. They're all scalar quantities. Are you getting that? Weight.
Vector.
Velocity.
Vector.
Acceleration.
Vector. Vector.
Torque.
Vector.
Moment.
Vector.
I'll call one that is out.
Change it,
I'll
that's
call
what
one
I'm
that
saying.
is vector. Distance.
Scalar.
I said it's our vector. Displacement. Vector. So electric field. I don't know. Electric field is what?
Scalar.
Vector. It's vector. Who's that person? Okay. So please, just what you just do on your own private study is to search examples of scalar. No, but then I'll tell you that which of the following is not a scalar. Very bonus question. Following is not a vector. Do you understand? Very simple and very fine. So what do I want to ask you? They don't have any business with scalar. They want to see your knowledge on what vectors. Okay? Now we are going to talk about different things about vectors today. Talk about
Magnitude.
we'll see maybe 5 things on vectors. 1. Just write this out for me so I'll know how I'm doing. And vectors talk about their representation. Okay, I talked about that one already.
Yes.
How do you represent a vector?
Arrow.
Using magnitude and
Direction.
and arrow. So first talk about resultants. How to find resultants of a vector. 2, we talk about the resolution. Resolution of a vector. How to resolve a vector. Okay. 3, we'll talk about unit vectors. 4, talk about addition.
See, can you hold on?
No, it's 4. Addition, just say arithmetic. You know what I mean by arithmetic? That's addition, subtraction, multiplication. So arithmetic of vectors. How to add, multiply, blah 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 of vectors. Okay, that's basically all. So let's go. Number 1, resultant. What does the word resultant mean? Results, total. If I give you one vector, or that vector, the total is the word resultant. Now, when you're totaling vectors, when you're to find the result of a vector, you have to pay attention to what? Direction. Take for example, Tunde, who's Tunde here? Okay, let's use Ijali. It sounds better. Tijani, another boy was like, okay, you want the, so give me, do you want it as card or account?
Cash.
I give it to her, say cash is better. I don't have cash.
Card or transfer.
Card or transfer.
Cash is better.
Just card or transfer.
Okay, transfer.
Guy revenge.
Okay, please let me check if my voice is. Sorry.
I like it.
Yes, cash or I don't have cash. Transfer or cash?
E-transfer.
Transfer. Yeah. If you like, forget before you leave this place. Tell me, so I'll send the money to you. Okay, so let's go. When I say result, I mean result of the vector. When you type vector, do you understand what I'm saying? Now, if I give you a scalar, I give you scalars. When you type it's just normal arithmetic plus. For example, Tijani covered a distance of 10 km from DLI to Gates, Inner Gates. Okay? From Gates, now I decided to come back to the library. Cover a new distance of 20 km. I don't know what he's looking for. He first went to Gates. From Gates, he came towards to the library. Am I dealing with direction? Am I telling you about direction? No. I'm only telling you that Tijani is just walking aimlessly.
Up and down.
Aimlessly.
Random.
He first walked 10 kilometers to Gate, then 50 kilometers to what? To library. From library, you now say you should go and see woman at architecture. You now walk an extra 2 kilometers to architecture. Now, what is Tijani's total distance? Distance covered. He walked 10, he walked 15, he walked 2. That's how many?
27.
27. Now we're not dealing with direction, so because distance is a scalar, we don't have any problem. We just do normal what? Plus. When it comes to vector, you don't do normal plus, so you have to pay attention to directions. Directions are very, 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 very important. If two vectors are acting on the same direction, parallel to each other, you add it up. If two vectors are acting on the same direction, parallel to each other but are acting on opposite directions, you will subtract. For example, see, this is a block. Okay, and now apply force in this direction. See, and somebody is pushing this block in this direction, and the force applied is 3 Newton. It's first a vector. It's first a vector.
Yes.
You can see that's why I'm putting what? An arrow sign. Then this person applying force of 3 Newton. Another person too is now pushing that block in the same direction again. That one has more power. That one has more. It's applying force of 10 Newton, but in the same direction. What is the resultant of the vector acting on the body? The resultant is what? 13. So we add it up. Why? Because they are in the same direction and they are parallel to each other. But in case we have it like this, let me fill the other marker, please. Now, in the case we have it like this, force is applied in this direction, and the force applied is 10 Newton. Okay? There's now somebody else applying force from this direction. C. Or let's say frictional force or whatever. And that force is 8 Newton. Because the two forces are parallel to each other, although they are facing opposite directions, what do you do? What do you do to get the resultant? You don't simply do what? You simply do what? Subtract with an opposite direction. So the resultant vector here is 10 Newton minus 8. That will give me what? 2 Newton. Is that one clear? Yes. Good. In the case where the vectors are perpendicular, like this, perpendicular, that means they are forming at the 90. What angle is between them? So this is a vector A, a vector B. And what angle is between them? Equal what? 90 degrees. How do you get the resultant? Note that the resultant of two vectors inclined at an angle to each other is the diagonal of the two vectors. Let me come again. The resultant of two vectors that are inclined at any angle at all. The resultant is the what? They are diagonal. If I complete this shape, see, I complete like this. Like this. It's forming a kind of square or let's say rectangle. Let's say the length are different, so to form a rectangle. Yes. Where's diagonal? Diagonal is from here like this to this point, isn't it? So like this, like this, like this, like this. See. This is the what? This is the resultant. This diagonal here is the resultant of the two vectors. Is this clear?
Yeah.
So the symbol for that is R. Class. For a rectangle, two opposite sides are what? Equal. If here is B, here is also B. If here is A, here is also what? A. That means if you can see, are you seeing the right angle triangle again?
Yeah.
See, I can bring it out. See, I can bring it out like this. Bring it out. Let me draw it well. What's this part? A. What's this part? B. What's this part? R. What's this part? Angle 90. Are we getting that? This is just like angle theta. Yeah. So I can find out. You know mathematics now. We have heard of Pythagoras theorem. Okay, Pythagoras theorem says that hypotenuse square, blah 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 blah. Okay, let's go. Now R square equals to A square plus B square. Hypotenuse square equals opposite square plus adjacent square. Do you understand that? So I can, if I take out the square root, the square from R, by taking square root of both sides, my R will be equal to the square root of A square and what? B square. This is how to get the resultant of two perpendicular vectors. Is this clear?
Yeah.
Simple, Abi? Good. If I give you a question like this, I said Adamu, no, Tijani. Tijani is better. Tijani, please write this down. Tijani walked from a point A in the northward direction. Where is northward? Up like this. Covering a distance of 4 kilometers. So you walk like this, a distance of 4 kilometers. That distance is displacement. Do you know why it's displacement?
Okay.
Because the distance has a direction. So the displacement is distance that has a direction. You understand? On getting to his destination, he now changed direction and walked eastward, covering a distance of 3 kilometers. Where is eastward? Like we don't know.
Right.
Eastward is from here like this. So you walk like this. Again. So I just like to walk 3 kilometers. He first walked 4 kilometers. He now walk 4 kilometers is 4,000 meters. You know what 1 meter is? 1 meter is like length of this board. It's approximately like 1 point something. Let's say from here to there like 1 meter. A meter rule. I'm using meter rule to estimate. It is like a meter rule, or maybe longer a little bit. So this is like 1 meter around here. So imagine 4,000 on a straight line. That's what this boy is walking. I don't know what he's looking for, but let's just assume that. So he walked 4 kilometers and walked for that was 3 kilometers eastward. And I said, what is his resultant? What is his what? Resultant. What I say resultant is, I said resultant is what? Is diagonal of two vectors, isn't it? Diagonal, if two vectors are making an angle to each other, is there an angle here? Is there an angle here?
Yes.
So because I'm making an angle, the resultant is simply the diagonal. Do you understand that? So I can bring this out like this, see, like this, to form a full rectangle. But where's the diagonal? This, I want to draw it like the way this one is. This is the what? Sorry, this is diagonal. Do you understand?
Yeah.
The diagonal is the resultant, that direction as well. This is the resultant, R. Class. If here is 4 kilometers, here is also what? 4 kilometers. If here is 3 kilometers, here is also what? 3 kilometers. Are you following? So if I draw this out, I'll be seeing, you're seeing a right angle triangle like this. Here is what? R, right? Here is what? 4 kilometers. And here is what? 3 kilometers. Isn't it? And here's our angle 90. Are we together, people of God? People of God, are we together? So how do we get R? Pythagoras theorem. So R is equal to the square root of 4 square plus what? 3 square. Are you following? So R is equal to the square root of 4 square is 16 and 3 square is 9. That would be the square root of 25. That would be 5 kilometers. So Tijani's displacement or Tijani's resultant is what? 5 kilometers. But what is Tijani's distance? Distance covered by Tijani is what? 7. Is it 7? Yes, 7. Distance covered. You first walk 4 kilometers. You now walk 3 kilometers. Distance does not have any business with direction, so you just add it up. But his displacement in a specific direction is what? Is how many? 5 kilometers. Do you understand that? 5 what? Kilometers.
It's also displacement.
It's also displacement. So this is Tijani's displacement from rest, from his start position. This is his displacement. Are we together, class? Now, what about if the angle is not 90 degrees? How do you solve it? For example, can I rub this? No.
Yes.
You have to dub fast, dub fast. Dub faster, dub faster. Sorry. It should be when.
Wait, why you sneeze out?
See, look at this. I have a vector. This is a vector. This is a vector. It's a vector now, because there's an arrow. This is another vector. Let's call this vector. Okay. Let's call this vector. Are we together? What's the angle between two vectors? What's the angle? This is the angle, Abby. Angle theta between the two vectors. Listen. Are the angles, are the vectors making angle 90?
No.
So can I use paragraph here?
No.
So what shall we do? We shall use yes. Now look at this now. We call it parallelogram law actually. Look at this now. I told you just now that the resultant of two vectors they are inclined is the what? Diagonal. If I can complete this shape, but the shape will not give us a rectangle like the other one, to give us a parallelogram. See. Do you agree?
Yeah.
A parallelogram. For a parallelogram, two opposite sides are parallel and equal. That means that if here is B, here is also B. If here is A, here is also what? A. Do you understand? I can draw this out like this. See, watch. If here is B, use your eyes and reflect it. If here is B, like this place is same as where? As here now, Abi?
Yes.
And what do we have here? A, and if here is B, here is what? Eh? Are you seeing the diagram I'm reflecting? I'm reflecting this part, I'm reflecting it here. That means that this angle here is same as what angle? This angle here. Are you seeing that now? And this angle here is also what? Theta. Are you getting that now? Are you with me? Good. So now, I said the resultant of this A and B is the what? Is the diagonal. Yeah, where is the diagonal of the parallelogram?
This by them.
Do you understand? So this here is the what? Diagonal. That is our resultant. How? Class, are you following?
Yeah.
Do you understand what I'm saying? So how can we find out? We use cosine rule. I don't know if cosine rule here. Yeah, cosine rule. We know that r square. Now cosine rule says c square plus c square equals a square plus b square minus 2ac equals angle c. Abi? Or a square equals to b square plus c square minus 2ac blah 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 like that. So it's the same idea. We have three sides. We have r, b, and a. So if I'm looking for r square will be equals to a square plus b square minus 2ab plus angle r. Do you understand what I'm saying? Plus what? This is the formula for this cosine rule now. In case you don't know cosine, this is cosine rule. People of God. Let's say it together. R square. This is I saw this question in your past question. That's what I'm taking it. R square equals what? A square plus b square minus 2ab plus angle r. What's angle r? Angle r is the angle facing what side? Side r. Angle r is the angle facing side r. Yeah, it's in a triangle here. Yeah. It's in a triangle.
Yeah.
See, not the entire parallelogram. Look at this one like this. This one like this. It's a triangle, Abi. So where's angle r? Who wants to come and point it? You don't want to. You don't want to show.
Show now, shows.
When fake things. All of that.
It's tight. It's not about fake.
Oh, yeah. Where's the angle? Is it this theta? No. It is this angle here. That is actually the angle. How? Are you getting that? See. If this angle is x, for example, x and theta. I don't know on a straight line.
Yes.
So I can say that x plus theta equals 180. Sum of angle on a straight line. What happened my x? 180 minus theta. That means that this angle here is what? 180 minus. Are you getting that?
Yeah.
So I can write this formula as what? Let's go. R squared equals to A squared plus B squared minus 2AB cos into bracket 180 minus. Are you following?
Yeah.
Are you following? Now, whenever I taught you guys quadrants, like trigonometry, where we talk about the first quadrant, second quadrant, third quadrant, fourth quadrant. In the second quadrant, theta is your angle is always 180 minus theta, isn't it? So now, if it's falling on second quadrant now, it become 180 minus theta, and cos is negative on the second quadrant. Are you with me? That means that what? That means that cos 180 minus theta is equal to minus cos theta. Do you agree with me? Yes. Pick a value. Pick a value of theta. Let's try it.
50.
No, guys. Second quadrant now.
Okay,
145.
145.
Let's try 120. Let's try 120. Let's say theta is 120. Let's see the statement that gravity is on. Let's see if it's correct.
Alright.
Then let's go. I'll give me cos 180 minus what's theta? 120. I mean now, I'm putting theta as 120 equals to minus cos 120. Are you following? Are you following?
Yes, sir.
So let's go. This is going to give me cos. Subtract. This will give me 60. Isn't it?
Yeah, go look at that.
Equals to what? Equals to what?
Minus cos 120.
Isn't it?
0.5
Yeah,
cos
check.
0.5.
What is cos 1? What is cos 60?
One
What do you
over
press
cos
calculator?
0.5
You get
cos
0.5.
0.5.
Press calculator. You get what? 0.5. Is it proven now? Yes. Is it true now?
But we
That
can
means-
use either of them.
Eh?
We can use either of them. It doesn't matter.
Either of what?
Either.
I'm just trying to. Why I'm doing this? I'm just trying to prove that this statement is correct. Are you with me now?
Yes.
Sorry.
Don't play with.
Okay. Statement is correct. And then we start up my other search things. Let me box it. Yeah, let's come down. So this statement is correct, Abby. So what can I do? I can remove cos 180 minus theta and put what instead? And put what? Minus cos theta. Let's go. Yeah, what's the formula now? Help me out. R squared.
Yeah.
This is where the plus is to come from.
R squared. Yes. I've seen that plot before.
Yes.
Are you getting it now? R squared equals to what? A squared plus B squared minus 2AB times everything here is what? Minus cos theta. That will give me R squared equals to A squared plus B squared. Now, minus can also give me what? Plus 2AB cos theta. Are we together? Now, the question now is that gravity couldn't share there. What are you stressing our life? This is what we know now, Abby. What's the difference between this one and this one? Your question is that, which one will I use to solve? Abby, when I give you a question, will I use this one or will I use this one earlier? Now, the thing is that you can use any one. But the difference between this one and this one is that the angle. This angle is the angle facing out, that's the resultant. This one is the angle between the two vectors. Usually in your calculation, they will always give you angle between two vectors. So it will be wise to use what? This. Because they will always give you the what? Angle between the two vectors. If I tell the angle between two vectors is 30, you can put the 30 here. Ewa. Like cold beans. Imagine you eating cold beans with cold garri. Like that combination is not good. At least it should be hot. So if you are giving angle between two vectors at 30 degrees, I'm going to put it here. Okay? They are gone. So what are you going to use instead? You're going to use this. So class, what's between this and this? What's different things to?
Angle between two vectors and angle
Which resultant?
Resultant. This is the resultant. Do you understand that?
Yeah.
Let's solve one question, then we remove. One question, then remove. If you're writing right, one question, then remove. Two vectors of units. Two vectors of units. Who wants sweet?
me.
Two vectors of unit. I know you say me. I bought plantain cheese for everybody, but I kept it at home.
Check out your work now. No. What's the name of the second?
I decided to buy Bablu instead because I know that I don't want you to kill people with your. You understand? I'm trying to consider everybody. Imagine now. Shane, what's your answer? Shane, answer here.
I've been picking it.
With your back, your mouth. Now I bought Bablu instead. So I'm buying this thing. So take. Yeah. Lick and cure that mouth odor. One. Let's go. Share it around. Two vectors of units 4 and 5. Two vectors of units 4 and 5. Two vectors of units 4 and 5 are inclined at an angle. Two vectors of units 4 and 5 are inclined at an angle of 30 degrees to each other. Are inclined at an angle of 30 degrees to each other. Of 30 degrees to each other. Are we together? Calculate the resultant vector. Calculate the resultant vector. Calculate the resultant vector. In the exam, there's no need to draw. That is only drawing now, but I'm teaching you, okay? In the exam, there's no need to draw. Shall we?
Shall.
Alright, we said two vectors. Two vectors, yeah. Two vectors are what and what? So that means a vector like this. Let me draw. This is one vector. This one is, let's say this one is 4, okay? Another vector. What's the angle between two vectors? 30. And will it be like this?
No.
That's 90 now. So if you use a sense, that should be like maybe around here like this. Okay? The other vector. And this vector is what now? This is 5. This is 4, this is 5. Are you getting that? They say find the what? What's the angle between them again? 30 degree. Find the what? Find the what? Resultant. Resultant. I said the resultant of two vectors is the what? Diagonal. Yeah, let's go. Let me just complete the diagram. I get that. And make it final. Not the final. So this here is the diagonal. That means this is the what? Why am I putting arrows since? Why am I adding arrows? I'm doing the vector, so please don't make that mistake. Directions are very, very important. You always add a direction, okay? So let's find this now. This part is obviously 30 degrees. So let's solve. I gave you a formula. I said what? R squared is A squared plus B squared plus 2AB cos theta. How am I using this formula? Because
we are giving the angle between the two vectors.
are we taking now? Okay. Angle between the two vectors. So it means that theta here is 30 degrees. So let's go. R squared, calculator out. A is what?
4.
So that's 4 squared, that's only 16, plus 5 squared, that's only 25, plus 2 into bracket 4 times 5, abi, cos 30. So R squared will be equals to 16 plus that will give me what? 41 plus
40.
that will give me what?
20 with 3.
No, now 40 now.
Okay, 40 with 3 over 2.
40.
Plus 3 over 2.
This is with 3
over 2.
over 2. Are we together?
Yes.
Okay. Please don't go and do. So some people can't do this. Let me show you something first. Some people can do 41 plus 40.
Times that.
80 constant.
Times it by this. Shayna, is it Bodmas you call that in Bodmas? You times first. Be careful, okay? Times first. So this time is first. So 3 over 2. So R square will be equals to, so multiply this first. 20 with 3 in decimals. In decimals.
34.6.
34.6 plus 41.
I think 75.6.
75.64. Are we getting the take square root of both sides? So I will be plus or minus 1. That's square root of 75.64. That will give me what? 8.70. Is it Newton? Okay, that's units. Let's just figure out as 8.70 what? Units. Is this clear now?
Yes, sir.
Yeah, you know something. If I use out that formula, now that says that what? R squared equals to A squared plus B squared minus 2AB cos theta. And not theta, angle R. I'll get the same answer.
Yes.
Where's angle R here in my diagram?
Down.
Angle R is this angle here.
60.
So if here is 30,
No,
if
150.
here is 30, here will be 150 minus 30. That will give me what? 150. Yeah, let's try it out. Yeah, let's go. R squared equals to 5 squared is what? 16 plus 25 minus 2 brackets 40. Sorry, 20. Abi, that's 4 times 5.
Yeah.
Are you following?
Yes.
Yes.
Then cos what now?
150.
150. Okay? So R squared will be equals, this is what? What do you get here? This is 41. This is minus 40
As minus
cos 150. Abi? So R squared equals, I punch this in calculator, what do you get?
Plus
Plus, so 41 plus what?
34 points.
Eh?
Oh yeah.
What's up?
Everything here. Everything here.
34.64.
34.64. Yeah, R squared will be equals to what?
Same thing.
75.
75.64. You can see it's the same as this. So whatever formula you use, you get the same answer. But this is wiser because we are giving the angle between the two vectors. If they give you a diagram, they didn't give you question. They just give you a diagram like this. They now do this. This is how the diagram looks like. They give you angle between two vectors.
No.
In this diagram, like this. If the diagram was like this, we're giving angle what? In this diagram, we're giving angle between two vectors. No, we're giving what? Angle out. That's one. So it's on now. It is wiser now to use what? To use what? This. They are giving angle out. Do you understand that now?
Yes.
Good. Let's go. Resolution of vectors.
Gravity.
Yes.
The question. Not just it. Again, just to see it.
There are questions. Wait, can just check. Okay. This is one. Resolution.
No.
Okay, this one. No, I didn't. I brought that one from my head.
Okay.
Down from my
Let's
head.
continue.
Down from my head.
So from get out. They will.
So the alpha, it was 20. For
What's the last one?
what's lost? At least that it is not bad for a night.
All right. Somebody say gravity. Let's move about blue. Oh. No. Online.
Oh really?
Okay. All right. Let's go. Resolution of vectors.
Who is the writer?
Resolution of vectors. Now you can talk to your neighbor now. You can talk to your neighbor. Map is on that thing. People are like before they're talking like this. So you're not catching them.
Not to get that on that.
But let's go.
You don't leave your
Solution.
Now, when I say this, oh, not too fast.
No.
When I say this, what happens is a revision, okay? When I say resolution of vector, you gotta look at the word resolution. Let me rephrase the word. I can say to resolve. When I say resolution of vector, I simply mean to resolve a vector. When I say to resolve, I mean to split a vector. Are we here?
Yeah.
To split the vector into components. I can take a vector and share it. I have a bread. I have bread, that big bread. That strong one of 500 or 400. Okay? And I can split that bread into 3 people or 2 people. Imagine I'm sharing. So I can share a vector into 2 different places or 3 different places. When you share a vector, it simply means what? Resolving a vector. Do you understand what I'm saying? Are we here? Look here. It only means to resolve a vector. If you are finished with it, better I stand up and walk around. Now, see. Imagine I have something like this. This is the ground. And I have a block. This block is in the ground. If I apply force like this, if I apply force like this, First apply like this. The first is a vector, abi? What in physics, there are three axes. Okay? We have the x, we have the y, and we have the z. For now, let's just stick to two axes. That's the x axis and the y. X is horizontal like this. Y is what vertical. Look at this force. In what axis is it acting? X. Which means that the force is on the x component or on the x axis. Is this clear now?
Yeah.
What about this force? If I imagine I'm pushing the block like this. Where is this force acting? It's acting on what? On the y component. So forces or vectors can act on different components, can act on x or act on what? On y. Do you understand what I'm saying?
Yeah.
But there are some vectors that are very stubborn. So them acting directly on x and y, they can act in between. For example, now imagine an arm vector like this. See, acting like this. Where is this one acting? This vector, where is it acting? Is it acting on x? Is it acting on y?
No.
It's acting like in between x and y. Now the thing here is that I can now predict, I can solve for the value of this f that is acting on the x and the value of this f that's acting on the what? On the y. By doing that, I have resolved the vector. Let me come again. Let me just do this now. I have a vector. This is a vector now. A vector. Let me call it vector f. I like using f. F is okay. Let me use b. So b makes sense. And let me use a. First of the alphabet. Let me say a is a vector. Is a vector true? Yes, but that's direction. That's magnitude. Now, where is a acting? Let me say this is a block. So a is like a force trying to pull the block. Do you understand? Now where is a acting? Is a acting on the x component? Both. Is it acting on the y component? Is it acting like in between them? Yes. Now the thing is that part of this a will aid in pushing this block in the x direction. Why part of this a will aid in pushing this block in the vertical direction? Do you understand what I'm saying? Yes. And you can calculate the vector and the magnitude of a that will act in this direction, and magnitude of a that will act in this direction. Are you getting that? This direction here, this direction, is called the x component. X component, or you can call it the horizontal component. Horizontal component. This one you are seeing here is called the y component. You can call it the what? The vertical component. So I can resolve a vector to the vertical component and to the what? Horizontal component. I wish I could prove it to you, but I'm doing revision. So let's do the formula straight and direct. The vector of A, the vector A that belongs to the x component is A cos theta. Is what? A cos theta. Where theta is the angle here between the vector and the. Are you getting that? Why the vector of A or the component of A that belongs to this axis is what? A sin theta. Is this clear?
Yes.
So the one that acts here is what, class? A cos theta. The one that acts here is what? A sin theta. Is this clear? So
Yeah.
what do you use to represent A cos theta? See, let me draw again. I like drawing. Not normal drawing. I like drawing rubbish. What do you use to represent A? What do you have in this part again?
Yes.
We have
A cos
theta. Have you? What do you use to represent it? We use AX to represent it. AX means x component of vector A. Okay? What do you use to represent A sin theta? We use what? AY. Ayomide? AY means what? Y component of vector A. Do you understand? So AY is the Y component of the vector A, and AX is the X component of the vector A. Do you understand? And why A here? A here is the what? You can tell me. Let me see if you are. Let me see how very. Thank you, resultant. I told you guys now. I feel like emptying my account on you. What I have in my account is 750. I also give this boy. I have to give this boy 500. What's the minimum?
We can manage.
But that is you accept IOU.
I need that.
Nine subs.
No, anything for you. No, I'm here for you. Anything for you. I can give you my life. As a life.
And your life, yeah.
My life, I'll give my life to Christ. So I can't give my life to this. I'll give my life to Christ. What do I have? Keep the same out of the house now. You think I have my laptop?
See your laptop.
Nothing else.
Bring it, you can sell it for
Not just transform it. You did that thing on purpose.
No, it was actually mosquito.
You hit him on purpose.
No, it was
There
mosquito.
was a mosquito now. Guys, I don't even feel I don't strong. They bite me.
See, what I explained now about two vectors and the diagonal is the what? Resultant. Abi? If you complete this like this, like a triangle. Are you seeing that now? Like, sorry, like a rectangle.
Rectangle.
If yes, AY, here is also what? AY. AX, here is also AX. So that means my A square will be equals to what? AX square plus AY square. Abi? Pythagoras theorem. Are we together? So if you take square of both sides, I say that what? A is equals to the square root of AX square plus AY square. Is this clear? Exactly. The same thing like I just did. R equals to square root of A square plus B square. The same thing. So A does the vector. So we're looking for the vector. When the vector is equals to square root of AX square, that means the square root of the X component plus square root of the square of the Y component. Do you understand what I'm saying?
Okay, that's the resultant.
This is the resultant, yes. Because listen, they can give you a question. Say find the resultant of the vector. And you're now going to be finding AX and maybe the X component and Y component. That's not the answer. The questions, when they give you a question, that question will lead you to finding the X component and also finding the Y component. After finding X component and Y component, you now use this formula to get the magnitude of the vector. You understand? You understand what I'm saying? So see a question now. See a question. How do you find AX? How do you find AX? AX is what? A equals that. How do you find AY? A sin. Is this clear? But then I can say you should find the angle. The angle. How do you find the angle? You find the angle. That's the angle between the two vectors. That's theta. Are we together? How do you find theta? See. Where's theta? Where's my diagram? Where's theta here? This place like this. How can you find theta? Now, AY is the opposite. Abi? Why AX is the what? Adjacent. When you remember SOCA 12, your trigonometry ratios, which trigonometry ratio or property has opposite and adjacent? Isn't that tan? So you can say that what? Tan theta, okay, is opposite over adjacent. It's adjacent. So what's opposite now? AY. What's adjacent? AX. So I can say that tan theta is AY over what? AX. So therefore, theta will be equals to tan inverse of AY over what? AX. So if I asked to find the angle between two vectors, just take the tan inverse of the Y component. I'm only using A as an example. I'm not saying that all your vectors will always be A, because some ways determine that, okay,
Maybe you should use R.
you can use R, RY, you can use F, you can use V, whatever. I'm just using A as an example, assuming that A is my vector. So the Y component divided by the X component, then you take the tan inverse of your division to get your theta. You understand? You understand? You understand?
Yes.
Let's see an example. Let's see an example. Let's see an example.
If you are still making your this thing, you have one, because I believe that most of you will have eaten it.
I need one.
Eating it. Like, where is it? Show it. You have heard it. Eating it rather. Okay, who is this?
I was expecting to raise up my
Anyone? If you are still making your own, that is the condition. I'm still making it. Where is it?
So nobody is making it now.
Let's go back to
Big boy.
you guys are written all these things. Not licking it.
All right, let's do example one.
The days to ask this. The days to ask this. Something like this. Just introduction.
I would say that's 60 degrees. That's 60 degrees.
Yeah, 60 degrees. So they said this is the vector. The angle of the vector is what angle is it making? 60 degrees to the horizontal. They said find the horizontal vertical component. See, you will let me not deceive you. They'll never ask something like this. It's not too simple. What they will ask you, they'll give you multiple vectors.
Exactly.
Multiple, so you should find everything.
That resolve everything.
One, resolve everything. I'm only giving you one first to start with. When I give you 5, if you guys shout upper court. So let's do one first. Okay, when we not do that one, then I'll start doing 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'll give you 10. Eyes I'll give you is 4 vectors or 5 vectors. They can't give you 5 vectors. You don't want to be mad. 5 vectors, no hour.
It's too much.
You can't give me more than 4 vectors. So let's try one vector first, okay? Now, I'm resolving these to what components now? There's horizontal. Where's the horizontal components here? So that means I have like this. This is 100 routine. These are horizontal components. Right? Let's say the vector is let me use f because it's force now.
Yeah.
So that means it's supposed to be fx, abi?
Yes.
Like 4x. Tell me what? Fy. Are we together?
Yeah.
Now note that. What is the? I told you guys just now. What is the x component? How do you get the x component with vector? F cos theta. Don't go and listen at that. Gravity. Where is the a that we use that time? There's no a here again. A there is just a prototype, just a format. So fx is what? F cos theta, and fy is what class? F sin theta. So let's go. What's my f? 100. Cos theta is the angle. The angle is what? 60. One your calculator. That will give me 50. Are we getting that?
Yeah.
F sin theta.
Sin
F sin theta.
theta is 30.
What's that going to be? That will be 100 sin 60.
60.
That will be 86.6. Am I correct?
50.
Yeah, it is something.
It's 6.6.
6.60.
Are we getting that? That means that the vector or the component of the vector acting in this direction here is what? What do we get?
66.6.
86.6 Newton. How about in this direction? Is what? 50 Newton. Okay? Answer us a question. How if you have an object here, how would that object move? Will it go like this or go up?
Go
Up.
Think. Use your sense.
Bit up.
Will you go to this side
This
with less
is the force
to go?
pulling this body upward in vertical direction.
Go.
This is the force pushing it like this. It's what? Up down.
It will actually maybe
It will go slide, it will go up. Not that it will go up vertically upwards,
Yes.
but it will go in this direction, to go mostly in this direction. You understand? But if I want this border to go like this along the ground, I have to do what to the angle? Reduce the angle. Think about it. Imagine a baby now. Why a baby can pull, why a small baby can pull his toy along the ground? Because the baby is short and the angle of inclination between the rope that he's using and the toy is lesser than this angle. If the angle is greater, if I increase the angle now to like 89, like 89 is like, how's 89? Imagine 89 degrees. How's it going to be from the ground?
almost to 90.
It will be like almost like this, Abby.
Yes.
When the object go up, do you understand? So as the angle tends to 90 degrees, the object they are pulling tends to go in the vertical direction. But as the angle tends to 0 degree, object tends to move on the horizontal plane. Are you guessing that now? So if I reduce the angle like 30 degrees now, try it. 30 degrees, yeah. That will be 100 plus 30. So that will give me 86.6 Newton. And 130, that will give me 50 Newton. So the angle, the values now will change. Here will now be 86.6, then will be what? 30. So by reducing the angle now, the object can now move where? Along the horizontal plane. Does that make sense now?
Yeah.
This is just for single vectors. Don't be too excited. Let's now do multiple vectors when you have more than one vector. This one clear? Thank you.
Somebody has a question.
Yes.
I thought if you want to resolve for the y component, you will do 90 minus 60.
Sorry?
I thought if you wanted to resolve for the y component,
No. Theta. Note, sharp. He asked that if you want to solve for vertical components, you want to use the vertical angle. No. That's a misconception. Theta is always the angle that the vector makes to the horizontal. Always, whether you are dealing with horizontal component or vertical component, the theta must be the angle between the vector and the horizontal component. Do you understand what I'm saying? So let's solve, before you guys start getting excited, let's solve for multiple vectors. We have more than one vector. Hope you are getting something.
Yes.
Yeah. I know you're trying to fight it. Fight it. Don't. Someone bought Pringles. And the people are rich. People are ritualists. Pringles. Everybody are using kuli for Pringles. We are using normal Pringles. Yeah? Wow. And you're not hiding it, so you're not calling, I'm not begging. Life isn't like that. Life isn't like that now. I know one day, I know I don't have money now. I know one day I can buy Pringles to one day. I've not even money to buy it before, but one day I know I'll have money to buy it. I don't care.
What? You don't care.
Can I have some?
Use that one.
I know. Can I
I
have
don't care.
Yes.
Yeah.
And I wanted to bring down my duster when I was supposed to. But I didn't just think of it. Just drop it.
You like it now. It's not about the yeah, mosquito.
Now, who buy you going? No, not
You can go now.
That's 3x.
Even if you sleep in this kind of place, right, you have problems. Because one, mosquito.
Number one.
Yeah, sleeping.
Who carry like this?
This
They don't even get power. One way back for school.
Any musketeers?
When you don't jacket to mosquito,
Mosquitoes in this place, they don't have any business giving malaria. Just to sort of blood. Just want to just drink.
not infect you.
3 mosquitoes here. Bite you. The blood have already finished. Like 10 liters. Gone. Wait, answer the question. How many liters is the blood of the average man?
Is it?
How many liters?
Liters.
5. Man, 5 liters.
Five.
No need to.
It's one.
I'm just
It's 5.
5.
So it's 5.
Shall we?
Out of robust.
How many liters?
I say average.
Average.
It's not exactly 5.
It could be 20.
20.
Ah.
For that average.
Actually,
You have blood now. Not see blood come out from my ear. You, like this. They play. You be like 2 plus 5. It's like 5 liters. Let's up.
Before the less.
How many vectors do we have here? 3 vectors. 1, 2, 3.
I saw.
Tabla boy. This part is here. The exam is next week.
That
No.
better too.
And again, your school is not how much? How much your school is now?
That better home.
166.
So it's expensive.
One.
Before our school fees was 5,000 naira. Now it's now 160. So it's down.
Okay, one and something. Something to go and study.
Now we have 3 vectors. The question says find the resultant force. The resultant vector. Find the resultant of the 3 vectors. Are you getting that?
Okay.
Resultant. Let me just say the vector is F. Are we getting that?
Yeah.
So what's the resultant? F is equals to square root. I mean now, square root of fx plus fy square, isn't it? Yeah. That means we have to find fx and find what fy. Fx means resolving them to the horizontal component. So let's do that first. So let's find our fx. Are we together? What am I resolving to the horizontal component? The vectors, Abi. But we just do it. It's simple. Just do it one by one.
Yes.
Take the vectors one by one. Yeah, let's start with the first vector. How do you resolve fx? Don't forget, fx is f cos theta, and fy is f sin theta. So let's start with f cos theta. F is the force. What's the force here? 10. Abi?
10.
Cos theta is the angle that force is making with the horizontal. What angle is this 10 Newton making with the horizontal? 0. This 10 Newton, not 2 Newton. 2 Newton is making 60 degrees. But this 10 Newton is already on the horizontal now. So what angle is it making? 0. It doesn't make any angle, so that's cos 0. Is that part clear? Is it clear? The next vector is what? 2. So that's 2 cos 60. Is it clear? Yeah. What will be the sign? The sign here will plus. Do you know why? Do you remember quadrants? Quadrant. All students take coke. Eh?
I like that.
Any vector that falls here, all means that sine, cos, and tan are all positive. Anyone that falls here means that only sine is positive. That means that this cos here will be what? Negative. Do you understand? What about in this quadrant? Cos will be what? Negative. What about this quadrant? Cos will be what? Positive. That means that cos, when resolving original components, cos is only positive here. Where is cos positive? This side, here and here. Are you getting what I'm saying? Don't plan where it's positive. Just know that all students take it. Do you understand?
Yeah.
So where is this vector falling? Where is it falling?
First
Yeah.
quadrant.
So we cause the positive or negative?
Positive.
Or times. It is what?
Times.
This is what? Positive. Right, let's go. Positive. Are we getting what I'm saying?
Yes. Minus.
Can I ask me again? Can someone let me take short clips?
Sure.
Your phone, please.
Me
Short
or
clips.
him?
This boy. Or your phone, anyone. You use your phone. Your phone is doing this kind of thing. I don't like it. Use your phone. Let me take short clips. Ma, I said, do you know what this is?
first.
We call this quadrants. There are 4 quadrants. Quadrant means angle 90. The quadrant is 90 degrees. When you have 4, that's 90, 90, 90. That will give you what? 360. Okay? So we have 4 quadrants. We have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. See, this is the first quadrant. This is the second. We count like this, anti-clockwise. This is the third, and this is the what? The fourth. Now this thing you are seeing here, all students, or ASTC, is an acronym. So remember where it will be plus and where it will be minus. This A means all. This S means sine. This T means tan. And this C means what? Guess. Cos. You know what they call cos, sine, tan? That's the trigonometry ratio. This all here, let me make it bigger. I'm going back to this one. I said all students take co. This all here means that any vector that falls in this first quadrant, that means in this first quadrant, they will all be what? Positive plus. That means that in this place, if a vector falls here, the vector falls in this quadrant.
It's positive.
All the trig ratios, that means sine, cos, and tan, they will all be what? Positive. Do you understand that? But if a vector falls here, it falls here, will they all be positive? No. Only one will be positive, which is what? That S sine. That means that in this any vector that falls here, sine will be what? Positive. But cos will be negative. And tan, what about tan? Negative. If a vector falls here like this place here, because of this place has an acronym of T, that means that only tan is positive here. That means cos and sine, they are what? Negative. If a vector falls here,
Positive.
only cos is positive. That means that sine and tan are negative. Now coming back to this now, what are we dealing with here? For fx, what are we dealing with? We are dealing with cos now. We're dealing with cos. Now, I'm resolving the vector one by one. Which vector did I just resolve now?
FS.
This vector, 2 Newton. Where is it falling? Is this first quadrant, second quadrant, third or fourth quadrant? First quadrant. And in first quadrant, I told you that all students take co. That means that in first quadrant, all of them are positive. That's why I'm having what? Plus. Is there a vector in this side? No. Where do you have vector again? Here. This is the third quadrant, Abby. Third quadrant. Thank you. Now, let's take the vector. Let us resolve it. That will be 3 cos what? 30. Clear? Now what will be the sign? Calm down. Do you know I got 3 cos 30 first? Yes, that's f cos theta. 3 cos 30. 30 is the angle theta. You understand? Now what will be the sign? Listen. All students take co. What is positive in this quadrant? Tan. What am I dealing with here? That means cos is what? Thank you. Negative. Simple. So let's go. Fx will now be equals to cos 0 is 1. Put that on your brain, your thick skull. Is there joint in your skull? What's it called, the joint? Is it movable or immovable? Make acid break. Let's one chill and mash your head. Let's go. Cos 0 is what? 1. So everything here will give me 10. Plus everything here will give me what? Everything here will give me 1. Check now. Check.
Yes.
What do you get?
1.
What do you get here? 1.
0.5 and so.
Press calculator. Don't use your head. minus everything you'll give me what?
3 times, that's 2 point something. 2 point something.
That's 2.59. Okay, so 2.6.
2.6. 2 point what do you get?
5.9.
2.5980.
598. Are we together?
Yeah.
Now simplify for me. What's my fx? Simplify. 10.8. Simplify now.
8.442.
8.402. Is this clear? Is it 8? Are you sure?
Yes.
Is this clear now for fx? Is this clear?
Yes.
Now, what do you have to find next?
FY.
Let's do the same thing. But now for fy, what's our formula? F sine theta. Am I communicating? So let's go. The same thing. F is what? 10.
10.
Sine theta is the same thing. 0. Are you getting that? What's the next vector?
2.
2 sine what? Sine what?
60.
Someone said that because I'm dealing with this one and I say the angle must be here. Theta is always with the horizontal. So that's the sign what? Sign
60.
Are we following?
Yeah.
Good. But what was the sign here?
Plus.
Plus or minus? Plus or minus? Otunla. What name can I call you? That name does not sit with you. My name is Olawale. What sign will be here? Yes. It doesn't even know where we are because we are looking at your bling, your wristwatch. Now you probably bought for 350 or 500 naira. At the bound that bridge there.
It's really.
What's it? Wait, you don't even know, he doesn't even know where we are. Looking
No,
at
I know where you are now.
Yeah, we come and point it.
I should come and point.
Yes, yeah,
Otilo.
Class, what will be the sign class? Plus. Why? Do you know why it's plus? It falls there. Now this one we call.
It's negative.
Let us resolve it. That will be 3, not cos of sine 30. What will be the sign?
Minus.
Minus or plus?
Minus.
Plus or minus?
Minus.
Minus or plus? Plus or minus? Why is it minus?
Stand.
You understand?
Yeah.
So fy will be equals to sine 0 is what? 0. This will give me
1. No.
2 times
2.5.
3. This will give me 3 now.
2.598 now. The same thing.
Everything together.
Yeah, simplify for me.
Minus 13.
1 point something.
Are you sure?
1 point.
That's what I got.
Do it one by one. What do you get here?
1 point something. 1.7 something.
1 point what?
732.
732.
1.7.
Minus what do you get here? 1.5. Have you now?
Yeah.
So our fy will be equals to what?
0.0.
0.232. That's our final answer. We've gotten fy and fx and we're done.
No.
What do you have to find? Resultant. So recall. It's simple, yes, it's simple. Recall that what? Is it showing something? Recall that what? F equals to root fx squared plus fy squared, isn't it?
Yeah.
So that f is equals to root. What's our fx? What's our
8.
fx? 8.402 squared plus what's our fy?
0.22.
0.232 squared. So simplify for me, please. Let's not waste time. Simplify. What do you get? Simplify. Calculator.
8.405.
8.405. Is this clear now? Is this clear? If I give you multiple vectors, just resolve them to x component and to the y component, and now use square f equals to square root of that square and that square to get your answer. Is this clear?
What do you have to find out to find the angle?
The angle now. Okay, let's do the angle. I told you guys, I gave you formula now that theta is tan inverse of y component over x component. That's fy over fx. Clear? Clear? So what will be theta now? Tan inverse of what's my fy? What's my fy? 0.232.
Even though it's negative,
What's my fx?
it will change.
What's my fx?
8.402.
Theta will now be equal to tan inverse of
0.
of what?
0.0.
Help me.
0.02.
0. What?
0.0276.
0.0276. Theta is equals to 1 point.
Well, it can't be 1 point.
Yeah. Are you sure?
1.5.
It's 1.
1.58. No problem. 1 degree.
1.58.
And I just coined the question. It was not really.
Yeah, it's fine.
Just as coined the question. So 1 point. Do you get the idea now? Yeah. So I'll give you one to solve. Then we'll leave this and go to limit vectors.
Someone said no, that, but you have explained it.
Okay.
When you explain that for those signs.
Okay.
And
Hope you understand it now. You understand. Okay, let's take this question.
What do you use the toilet?
is it gravity that has? They are talking as if you are the owner of this place. So you want to use it.
What's the last point? Who your government?
What is that?
All right.
The top building. I told her to go to the Senate house. Hey, those beginning. Honestly, I was
All right. Find the resultant. Find the resultant. I'm giving you just 3 minutes. 3 minutes to find the resultant. 3 minutes. Okay, the first person again. The five, yeah, I'll go. 100, 160. Okay. The first person gets 500 naira recharge.
That's 100. No, 1 million.
So what degree is that?
45, 30, and 20.
Listen.
So please. Anyone that solves this without asking question.
You don't want 60.
I don't know.
That's what I was doing.
That 100 or 160 for the third. There's no 160, it's 100. 100. So is that 160 or 100?
That down.
I give you 1,000 naira.
This 1,000. Hey.
1,000 naira.
Hey, don't waste my time.
Don't call my power bank.
People are
Now
not
I'll use
calculator.
that.
Ah, God.
Also, you guys are really serious. Wow.
After you do not get it.
Oh, God.
Don't leave this to the boys. So I want the answers from the girl. You're done.
I have calculator.
See, buy calculator. Please.
I have with the
Don't do that. You're a scholar and you carry your head and go to exam hall. Don't do that. Buy a calculator, okay? 1 more minute.
David, 179.98.
Okay, somebody gave an answer.
179.98.
Yeah, 178.8.
Second person.
178.86.
178.86. I like that. That dynamic difference.
But it's what I got now.
The person, one person.
178.85.
You should calm down now.
Why someone gets different things?
0.85.
That's of mine directly.
178.85.
So
Okay. 30 more seconds, then I round up and we solve.
101.
168.73. Gravity, right? 178.85.
8.73.
Gravity.
187.
Gravity.
Do I have my own down?
Gravity.
Do I have my own down?
Yeah, your own is what?
Gravity.
101.
101.
Gravity.
187.
Gravity.
0.7.
Oga, I'm not doing one.
Give me one.
5.8.
Gravity.
I'm seeing radio stations here.
Gravity. Gravity. Calculator means the right. Change on to 8.85. No, change that 9 to 8.85.
Sir, look
I got this face now. The calculator was 178.85.
Sorry, man, look,
If I saw it in the, if I saw it, I'll get it. Get that 178.85. That 9.
Okay,
The calculator.
It's not the third one now.
Gravity, change it now.
If I'm changing, I'll bring it down.
No, gravity. I was the face now. It's the calculator. That's not my fault. 178.85.
If I'm changing, I'll bring it back.
No, gravity. 178.85 now. Gravity don't like that now.
I'll take it down.
Gravity 178.85 now.
Yes.
Gravity 178.85.
165.62. Well, let's have it together.
Gravity, change my stuff now.
I'm not changing this stuff.
Gravity is not fair.
Sorry.
You don't want me to win. You want to give it to this stupid boy.
There's nothing fair in
There's Afolabi that still won now. 178.86.
Who got this one?
Afolabi is the one that got it.
Afolabi can go 178.85.
Yeah, let's do it. Let's do it.
You have to
together.
change my value first now.
I'm not changing any value.
calculator.
Buy a calculator. Buy a good calculator. Don't go and buy people. Buy cashew.
Gravity is not fair.
Sorry.
I got it.
Life is not fair, bro.
I got it.
Life is not fair.
Sit down, but on the night.
So let's find FX. Let's find FX. Very, very fast.
That is
Let's
it.
go. Let's go. This one.
Second one.
Second one. Let's go. FX. Shall we? FX. Alright, so many vectors are one by one. Hello. What's the first vector here? 100 cos 45, isn't it? What's the second vector? 100 cos 30. Now, what will be the sign? What will be the sign? Why is it minus?
Because of
Second quadrant. So it's negative in the second quadrant. Cos is negative there. What's the next vector? 160 cos 20. Abi? What will be the sign? Minus. Because cos is negative here as well. Are you following? So our fx will be equals to, quant for me. Express everything once, calculator.
Minus 160.
This is 160.
minus
Minus
160.
116. That's when you
24.
26.
just 24.
24 Newton. Abi, that one is clear, Abi. Who got fx at least? You know the fx?
I got it.
That boy. So it's not that.
Yes, I know that there's 20 there.
Yeah.
No, just adding 0, cos 0.
So you adding cos 0? How many is cos 0?
So I would not get like minus 9.
Is this sleep or Gary?
Sir, it's sleep.
Which one affected you? Is this sleep or Gary?
Let's say this.
The two. Alright, let's find fy now, shall we? Hello? Let's find fy. Now for fy, the same thing. Let's do this one. Ma, you follow? For this vector is what? 100 sine 45, isn't it? Hello? For this vector is what? 100 sine what class? 30, Abi? 100 sine 30. But all now be the angle, all be the sine rather. Plus, because this is second quadrant. Sine is positive in second quadrant. What about this vector here? 160 sine 20. What will be the sign? Negative, because sine is negative in this quadrant. Please permit me to clean this diagram. So let's solve. Press the calculator. What's that?
I said the camera is not clear.
65.9.
How about now?
Okay, it's clear now. It's this thing, a resolution
Okay.
from our end.
Exactly. I can speak English like this. It's not like you
Fine. If your camera is not clear, just increase your
Who is that talking to?
YouTube resolution.
Okay.
It's low, so increase it. Like 720 or 460. So go to your option, increase it to 450, 460 or 720.
117.85.
Are we together?
65.99.
Okay, what do you get?
65.99.
55.99 Newton. Final answer, that's the end.
No.
So F will be equals to square root of fx squared plus fy squared. So F is equals to square root of, what's the fx?
Minus 160.
166.24 all square. The square should, the minus should be in the bracket, okay?
Yeah.
Plus, what's the fy?
65.99.
55.9
9 what? 9
Square.
Yeah, cross calculator, what do you get?
178.85.
178.85.
Yes.
85 or 86?
85.
85 what?
After S5 is what?
I not check.
After 5 is what?
You need to check.
Check.
86.
It's 86. Let's clap for Forbes.
Who be Forbes?
Forbes now, not Forbes. Afolabi.
Oh.
This
Yes,
22 is
now.
correct.
Huh?
It's a bit correct. This is number 3.
Yeah, 3 is also correct. But it's correct, it's correct. But Forbes was expected to give the answer. And even give a very, very correct, accurate answer. 0.86. Let's clap for that boy again. It's too good. You don't need to be a scholar.
Calculator.
Just calculator, if you do calculator, you get your answer. Don't be using your brain. I know you have brain, but use calculator. So that's the answer. So I owe you 1,000 naira. Send me your answer.
You don't set down now.
No, no.
It's not you.
So all the two answer and
9 now.
all the two answer and this guy answer.
Let's be realistic here.
Yours
Let them
is
share
fine.
it.
This is- And you answered before you.
Let them
Oh, yeah.
share it.
Oh, wait. It's
You answered
You
before
sit
you.
down, bro. Don't different.
yes or no?
That's smart as this answer.
You win.
No, gravity, this is not fair. You are
Sir.
giving to the less privileged for me.
Sir, small now. 3 and 2. What is the difference?
But you came first now. You answered first.
But I answered first.
This is Forbes.
You see, you approximated.
But I answered first.
But you
But you failed it.
Look at the difference between these answers now.
now.
If it was doing injunction, you can't tell that one
It's not about option. They told you to sell it manually. You still fail it now.
Just see me follow you.
Yeah, failed.
objective requires you being smart, not
Okay,
being
sir.
Gravity.
Hey.
Maybe there's no G. Gravity.
What of
Gravity.
write that down.
No.
Maybe there's no G in the question.
There is no.
Give the right phone and the money.
Send me your card. On the
Calm
card.
down. What value of G?
I'll give you card on the naira.
Pascal 100 now.
Big boy. Man, decide this for me.
Unit vectors.
Alright, let's go.
Unit vectors.
I need better for this.
Unit vectors. Unit vectors. Unit vectors. Let's go. Unit vectors are dimensionless vectors. Unit vectors are dimensionless vectors. And are represented by I, J, and K. They are what? Dimensionless. That means they don't have a dimension. And they are represented by what? By I, J, and K. One thing you should notice is that every axis have its own what? Unit vector. Basically, we have 3 axes. Now, normally we have 2, X and Y. But in physics, we actually have 3 axes, X, Y, and what? Z. So there are 3 axes. Watch. See. This is the X axis. Okay? This is the Y axis. And this is the what? The Z axis. Every axis have a unit vector. Do you understand? And how do we represent unit vectors? We use 3 letters. We have I, we have J, and we have K. This I is a unit vector. Which is a unit vector. This K is also what? A unit vector. They all belong to different components. For the x-axis, the unit vector here is what? Is I. Do you understand? For the y-axis, the unit vector is what? J. And for the z-axis, the unit vector is what? Is K. Whenever I see K, that associated with what? Associated with the Z component. Whenever I see I, it's with the X component, and so on and so forth. Now, when you are using unit vectors, how do we now represent a vector? How do we represent a vector using unit vectors? It's different from the one we just finished doing. For example, now I have it like this. I have a vector like this, a vector A, a vector A. Now in this A we have components. It has the AX component here, Abby, and the AY component here. Are you getting that? What do you call this AX and AY? We call them component vectors. Abby, we just need to do it now. Component what? Vectors. They are component vectors. So AY is a component vector, AS is a component vector, AZ is also what? A component vector. Do you understand that? So every axis we have a unit vector. So that means every component vector has a unit vector. Do you understand? That means that the x component here has its own unit vector. What's the unit vector of the x component? What about for the y component? J. So here we are going to have I. Are we getting that? Yeah, we are going to have what? J. So now the vector A is when you add the two of them together. You multiply the component vector and the unit vector of every axis. I'm speaking English. What's the component vector here? Component vector. What's the unit vector? Multiply, what do you get? AXI. What's the component vector here? AY. What's the unit vector? J. Multiply, give you what? AYJ. When you now add it together, AXI and AYJ together will give you the vector A. So that means that vector A here, A is equals to AXI plus AYJ. This is for two-dimensional vector. If I have three dimensions, what's it going to be? ASI plus AYJ plus AZJ. If my vector is B, what will now be the vector representation?
Yes.
Equals to BXI plus BYJ plus BZK. My vector is D. What's going to be? DXI plus DYJ. You get the idea? Do you understand that? Do you get that? You get that now? Let's take for example, I have a vector like this. Take for example, you know A is what? What's the format? AXI plus AYJ plus AZK, isn't it? This is the format for representation of a vector. Are we getting that now? Let's say for example, now give a vector, and the vector is A equals to 3I plus 5J minus 6K. If you have sense, I know all of you have sense. Physical and online. Use your eyes and compare. Compare it. What's AX? 3. Oh, you're smart. This thing here does nice, very, very dangerous. Lying down and leaning. Small breeze will blow like this. And you just close your eyes.
I'm not that type of person.
Before you know, open your eyes like this. Say, okay, what's our AX here? What's our AX? 3. What's our AY? 5. What's our AZ? -6. So the component vector is just the coefficient of the unit vectors. So you'll be able to identify a component vector when you see one. So this is how we can represent a vector. Apart from the one just using magnitude and direction, we can also use what? Unit vectors and component vectors to represent a vector. You understand? If I give you something like this, I give you this. B equals to 6I plus 6J. Is this a vector?
Yes.
No, although I didn't put all those arrows like the other ones, but at least you can see I and J. Once you see that, know that it is a what? It's a vector. I give you B equals 10. Is it a vector? No. If I put unit vectors like this, it becomes what? A vector. Do you understand that? Now we can add two vectors. We can add them. We can subtract. We can multiply. We can divide, but we're not going to do division. So we want to do addition and subtraction, and also what? Multiplication of these vectors. Are we together now?
Yes.
Good. Let's start with the simple ones. Let's start with addition and subtraction. That's right. Yeah, right. What's that? 3. Time is relative. Just now, we think, it doesn't look as if we have spent up to 3 hours. You feel it? Let's go. 2I minus 4J. There are two vectors here.
Let me see. Okay.
If I were watching online,
Like 15.
and they are much.
They were 20.
Some of the guys
5 minutes to stretch.
No, I'll give you a short break now so you can walk around and come back. Okay. Look at these two vectors. Let's look at this. Are they vectors?
Yes.
Are they vectors? Yes. Thank you. We can add them, Abby.
Yes.
I got this. You can add them.
Parrot.
Let's say you want to do A plus B. Hello? A plus B. You want to add A and B. See, it's not simple sense mathematics. What's A? A is what? 3I plus 6J. Plus what's B? 2I minus 4J. Note that you can add similar vectors that have the same unit vector. You cannot add J and J normally. Okay, let's don't forget unit vector set. Normal mathematics, collect like terms, I mean.
Yes.
You can add like terms together. So this is our same idea. So I can add I to I. Do you understand? That means that 3I plus 2I will give me as 5I. And plus 6J minus 4J will give me what? Plus 2. That's how to add 2 or more vectors. Is this clear?
Yes.
If I say to subtract. Subtract, like A minus B. Let's go. A minus B. What's my A, class? What's my A? 3I plus 6J. Abi now? Minus, what's my B?
2I minus 4.
Now, there's a problem here. Because of we are dealing with minus sign. Minus is very dangerous somebody. So what will you do? You have to put this in the words in this bracket. Because minus will affect the B. Do you understand that? So let's go. So give me, please don't forget this. So give me 3I, okay, plus 6J. I asked someone to this for me, did you?
Yep.
Not me. Did you ask someone to?
Yeah, I did.
Not me.
Everybody. You know.
Everybody. I did of them too now. I'm very smart. I did.
Yeah, open the bracket. Not beginning to have minus
Minus 2I plus 4J.
Please do. So let's do the same thing. 3I minus 2I will give me what?
I.
I. 6J plus 4J will give me what? 10J. So A minus B is equals to I plus 10J. Addition and subtraction is the simplest thing ever. It's very simple. Yes, now, is it not clear? Why are you doubting your own ability? I know you are good. You are brilliant, you're smart. But you are doubting yourself.
Nonsense.
You have sense. She's a very smart person. But she's doubting. She's not, you don't have confidence. When you pass the exam, you have to have confidence. You have to, if you don't have confidence, forget it. Seeing the question like this, you are dead already. But you feel that, even when you know it, though, they give you the math A plus B, you know it. Because of that fear and that lack of confidence. Even when you solve it, you get the answer. I'm not sure. Isn't the option, no? But what of if you're not sure, you're not confident in the answer? So what you need to do is to solve past questions. Stop past questions. Stop past questions. Eat it. Solve past questions back to back, back to back, back to back. What I advise you to do, any topic you learn, solve all the questions on that topic. Like today now we've done dimension and we've done scalar and vectors. Solve when you get back to your house, your hostel or whatever, wherever you stay. Under the bridge. Solve all the questions. Solve all the questions that you can find on scalar and vectors.
Before they tell you to solve questions,
So let me go and sleep, like 2 hours sleep.
See, I'm trying to motivate you and see you're motivating me back. It's about finding motivation. Yeah. So that's for addition and subtraction. For multiplication, take for example, I said find 2a. Find 2a plus 3b. Find 2a plus 3b. Hello? Find what? 2a plus 3b. What's our a? Our a was what?
3I plus
3i plus 6j. And what's our b?
2I minus 4J.
2i,
2I minus 4J.
So what will be 2a plus 3b? Let's go. 2a plus 3b will be equals to 2 times a, Abby? What's my a? 3i plus 6j plus 3 brackets. What's our b? 2i minus 4, just like in normal mathematics. Are we getting that? The normal mathematics. So let's go. 2 times 3i, 6i plus what? 12j plus what? 6i minus what? 12j. Are we getting that? So let's go. 6i plus 6i will give me what? 12i. 12j minus 12 will give me what? 0j, isn't it? So that means my 2a plus 3b is equals to what? 12i. Is this clear?
Yeah.
Is this clear, class?
Yes.
They can put the answer in the form 12i plus 0j plus 0k. It's the same thing. Is this clear, class?
Yes, sir.
One last one, I'll now give you a short break to walk around. If you want to walk around. See, look at this one. Look at this one. Given that A is -1, 6, and 5, and B is 0, 2, and 4. Find A plus B. These are that form. Are you seeing IJ and K here? There's IJ and K, but it's spiritual. Do like this. Do like this.
I see the
Do like this. You see it. Try trust me. Put my this can play. Do you see it now? Do like this. You see it. You see one eye. See eye. You see the eye. So what happens here is that this first thing you're seeing here, this one here, is I.
I'm just putting the eye.
Do you understand? This one here is what? J. This one here is what? K. Do you get what I just said? Hello, do you get what I just said?
Yes, sir.
This I, this J, this K, this I, this. So you do it for me. What's your answer?
minus I.
Minus I.
I
plus
okay, 6
J plus 5K.
So you have to put a comma.
Okay, addition of
separate them. Don't be too smart and say your answer is minus I plus 8J plus 9K. Don't be too smart. You don't need to bring back the K. They didn't show you. They didn't show K, IJ and K here. So same way, don't show your own IJ and K. Just put it in parenthesis. Is this clear, class? You understand it?
Yes.
You understand?
I do.
See, this is I. This is also I. I add you plus it together. Minus I plus 0. I'll give you what?
-1,
Minus
8
1.
and 9.
How about this part? This is J, this is J. I add it together. It doesn't to you, mommy. 6. Okay, no, that's one. 6 plus 2, 8. 5 plus that. 9. Don't go and do it. Some of you now can say -1 plus 8 plus 9. Add it together. Don't do that. Yeah, you cannot add it together. You know that. So this is I, this is J, this is K. They have different unique vectors. So let's go. The next thing is multiplication of vector. This one is madly important. Wait, let's finish it first. Multiplication of what? Of vector. This one is madly important because trust me. If Unilag, if Unilag will give you any question on vector, they will not escape this one. Now, wait, calm down. I know you want to calm down. Now, if you want to multiply two vectors, how do you multiply two vectors? There are two methods. We have what we call the scalar product. And we have what we call the vector product. What's the difference? This one when you're multiplying, when you're dealing with scalar quantities. So when you're dealing with what? Vector quantities. Another word for vector product is what? Cross. Keep quiet. Another word for vector product is what? Is cross product. We are live. I need to shout. Scalar product is what? Dot product. Vector product is what? Cross product. When you say cross, that's cross product. When you say dot, that's what? Dot product. So let's start with dot product. Very simple. That's the simplest. Then I'll now leave you, now come back and do vector product. For cross products, let's say we have two vectors. A is AXI plus A. This is just a format, a bit.
Yeah.
And B is what? BXI plus BYJ. So if I say what is if I say I want to multiply two vectors, I want to use what now? Dot product. So we do like this. A as the word implies, dot. So A plus what? B. Are you getting that? So A dot B, what do you do? In for dot product, I times I will give you 1. Okay? And I times J will give you 0. If you now expand, don't need to expand, don't worry. But if you explicitly expand, as this times this, you expand. What you'll be getting is this. You'll be getting AXBX plus AYBY. Do you understand that? Which means that if you are given two vectors and you want to do vector product, dot product, what do? Just multiply the component vectors. Hello. Multiply the what? Component vectors. Are you here?
Yeah.
This, once you multiply the component vectors, we get the dot product. Let me give you an example. I have A to be 3i plus 6j, and I have B to be 6i minus 4j. What's A dot B? A dot B, follow the procedure. You just multiply the components. That's this times this will give you what? That's 3 times 6. Are you getting that? Then plus what? 6 times minus 4. Are you following? That will give me 18 minus 24. That will give me what class? Minus 6. Is this clear? So just multiply the components. The components. Just multiply the components alone. Forget about the unit vector. X component multiply them, Y component multiply them, Z component multiply them, add your answers together. That will give you the dot product. For cross products, that one you have to bring principles of what matrix. Okay? But since some of you want to take a walk, so I'll give you 5 minutes. 5 minutes. Take a walk. Let's finish this thing now. So I don't know why. I'll give you just 5 minutes. Take a walk. Just stand up, take a walk. Just walk and come back. Don't go and close your eyes.
It doesn't have unit, have you? Because it's multiplication. Because of multiplication.
Yes.
So now your brother.
She won't collect her for you.
Yeah. That's
Chemistry.
No, I have to finish
You have
something.
to use your hand and
All right, for the cross product.
Hello, come
For
around.
cross
Though.
products is also called vector product.
Come around, though.
Vector product. So take for example, I have two vectors. I have two vectors. A to be AXI plus AYJ plus AZK. And I have B to be BXI
The two of you stay in same
plus
place.
BYJ
Like that.
plus
Oh, yeah.
BZK. If you ask to find the cross product of A and B, it's sensible. If you ask to find the cross product of A and B, so A cross B, that's the symbol A cross B. And what do we use? We use the concept of determinant of a matrix. Use matrix. Let's just make this very, very fast. Okay? It looks like this. Looks like this. You have your I, your J, and your K. Okay? So we use the component vectors here. Component vectors we have here for X, for A, is AX, here is AY, and here is AZ. And for this part, we have the BX, the BY, and the BZ. Are we together? So I don't want to solve using this one. Let us use the real values so it makes more sense. So let's take for example, so this is the format, this is how it looks like. And there we solve using determinants of a matrix. I believe that everyone has knowledge on determinants of a matrix. Okay? So take for example, I have two vectors. I have A to be 3i plus 2j plus 2k, and B is 2i minus 4j minus k. Okay? So how do we solve for this? If you have to find the cross product, so A cross B is equals to, let's go, is equals to, here we have our I, we have our J, and we have our K. If you want to talk, go away. Don't let me send you away. Don't talk. Just step out. When you are doing it, come back. You're distracting me. Alright, so let's go. So the component vectors are 3, 2, and 2. So write 3, 2, and 2. Y for the B, we have 2 minus 4 and minus 1. So how you solve the determinant of the matrix is very simple. Let me go off the top parts. You have enough space on the board. You're talking. You're not anything because you're talking. I was hearing your voice from you. If I take out this part, take out I, A cross B, take out I, what do you have left? We have 2, 2, minus 4, minus 1. So you multiply this and this, minus this and this. Okay, let's go. This has to give us what? It will give us minus 2. Then minus, this will give us what? Minus 8. That will become plus 8. Are we getting that? Then, now note that J is always negative. So minus J into bracket. Now if you take out J, what's left? You have 3, 2, 2, minus 1. So you multiply this minus this. Are you getting that? So this time this will give me what? Give me minus 3. Have you? Then minus this times to give us what? 4. Isn't it? Then let's move to the next unit vector, which is what? K. So take out K. Take out K. What is left? 3, 2, 2, and minus 4. So multiply 3 times that, 3 times 4, minus 12, minus, this has to give us what? 4. So A cross B will be equals to, this will give me what? 6, have it? 6i, right? This will give me what? Minus 7, have it? 7 times minus j will give me plus 7j. To give me minus 16. Give me minus 16k. So this is A cross what? B. So you can notice, what do you notice here? When we did dot product, we got scalar as our answer. And we got a normal number as our answer. But when we use cross product, we got what? Vectors as our answer. So the vector product will give you a vector answer. And scalar product will give you what? Scalar answer. You understand that? That's how to do cross product, as simple as that. And sometimes, Your vectors may have angles between them. For example, you have vector A and vector B. There's not an angle between vector A and vector B. I say find the angle between vector A and vector B. How do you do it? See. See. Okay, what can I write? See. Every vector has a magnitude. Abi? You can find the magnitude of a vector. When you are given the x-axis and the y-axis, you can get the magnitude of the vector now.
Yes.
By using that A equals square root of blah 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 ax squared here, ay squared. So if I give you a vector like this, I give you a vector like A equals to axi plus ayj plus a. This is the format, Abi. What will be the magnitude of A? That will be square root, Abi, of ax squared plus ay squared plus az squared. I believe this is clear from what we just finished in the previous part. So if I give you a question like A equals to 3i plus 2j plus 6k, what will be the magnitude of A? A will be what, class? Square root, Abi, of, compare now, that's 3 square plus 2 square plus what, 6 square. Are you following? I did the same, what I did here, I'm doing the same thing here. So the square of the component vectors, when you take the square root of the square, when you take the square root of the sum of the square of the component vectors, you get the magnitude of the vector A. So A is equal to the square root of 49. 3 square is, everything here is what? 49. 49. That will give me what, class? 7. Do you understand? That's how to get the magnitude of a vector. Sometimes, instead of them writing A like this, they put straight lines like this. So straight line represents, this line means magnitude of A. Do you understand that? If I give you two vectors and say find the angle between two vectors, how do you tap that one? How do you do it? How do you do it? There's a formula. The formula says that A dot B is equal to magnitude of A times magnitude of B cos theta. Okay? Where A dot B, what does A dot B mean? A dot B means cross product of A and B. What does this one mean? Magnitude of A. This one means magnitude of B. This one means cos theta. Theta is the angle between the two vectors. If I'm looking for the angle between the two vectors, I can make theta the formula B. If I divide both sides by what? By this. All I get, I'm having cos theta equals to A dot B over magnitude of A times magnitude of what? B. Isn't it? I'm dividing both sides by this. So from here, theta will now be equals to what? Cos inverse. Abi? So I'm going to have that theta is the cos inverse of A dot B magnitude of A times magnitude of what? B. And the thing here is that this is how to find the angle between the two vectors. But the thing here is that you don't need to cram this one. You don't really need to. What you just need to know here is which one is this one here. Just know that A dot B is magnitude of A, magnitude of B cos theta. With that, you can collect similar terms, and so you can divide both sides and find your angle between the two vectors. Is this clear? Let's see an example. Let's see an example. Let's see an example. Given that, right? Given that A is minus 6, not 6, it's too much. Minus 3i plus j plus 6k. Let's just do it two-dimensional, no time. And B is I minus 4j. That's A and B. And I said find the angle between vector A and vector what? B. Find the angle between vector A and vector B. Sound show me. Let me check. Sound said I can't. You can't hear me. Let me check. Let me check.
That was the way you were late.
Okay, so let's find the angle between A and what and B. Shall we? Yeah. What's our formula, class? Our formula is what? A dot B equals magnitude of A times magnitude of B cos theta. What's my looking for in this thing? All this is there. I'm looking for theta B. But I need a lot of things. What do I need first? One. I need A dot B. Abi?
Yeah.
I need magnitude of A, I need magnitude of B. So let's do that very, very fast. Let's find A dot B. A dot B, A dot B. Yeah, sharp, sharp. How do you do? I told us to show how to do A dot B now. Yeah, that was minus 1 times 1. Sorry, minus 3 times 1. Minus 3. Yeah, okay. Then plus 1 times minus 4 is minus 4, isn't it?
Yeah.
That will give me what? Minus 7. That's A dot B, isn't it?
Yeah.
Let's find the magnitude of A and magnitude of B. I can show you a shortcut. You can give me a calculator, please. Let me show you how to do that. So what you just do, shortcut and how to get magnitude of whatever. You press your shift. Press your shift, and press. You see this HYP.
Yeah.
HYP. On it you see ABS.
Yeah.
You see ABS, Abi? That ABS means absolute. So press your shift and press that absolute. You see two lines like this.
Then.
Have you seen it?
Yes.
Now, put your value. What's A? Minus 3 plus 1, Abi? Minus 3 and 1 now. Minus 3I plus J. Do we have? We don't have more than 1. Oh, okay. We can only use only I here. Hey, you can still do that. You can say, let's try it. Minus 3I.
Is that I?
Yes, I, yes.
Wait. How do I? Okay.
Okay, let's try it again. Okay, before you do that, we need to set the mode. Change the mode to complex. Change the complex. Complex.
Okay.
That's mode and 2. That's complex. Then press shift and absolute. Then what do we have? Minus 3I plus J. So minus 3I. I is that's ENG. Have you seen it? ENG, that's I. Then plus what? J. But since we don't have J here, just press 1. J, the equation of J is what? What's the equation of J here? 1. So press your 1. What did you get? Root 10. Let's see if it's correct. Let's see if it's 10. Root, absolute value of A is equals to square root, Abi? Square root of this square and this square, isn't it? That's minus 3 square plus what? 1 square, isn't it? That will give me square root of what's minus 3 square? 9. What's 1 square? 9 plus 1, 10. Is it correct? So you can really use your calculator to get the absolute values of A and B instead of using your hand. So let's go again. For B, let's try it again. What do? You press shift what? Absolute. Have you seen that? Then put the values of B. What do we have? This is I. Then what?
Root 17.
Then minus 4. What did we get? Root 17. That means that the absolute value of B is root of what? 17. Are you following?
Yes.
I know you want to sleep, just
I'm following.
fight it. It's the devil working. Fight it. So we have gotten the absolute value of A and B, Abi?
Yes.
So what we have to find, class? These are main formula.
Angle.
I have to find the angle. Yeah, let's put everything into the equation. Are we getting that?
Yes.
What's A dot B? What do we get?
Minus 7.
Minus 7 equals, what do we get as this one?
Root 10.
Root 10 times, what do you get as this one?
Root 17.
Root 17 cos what? Theta. So this will give me minus 7 equals to multiply this for me. Multiply for me, use the calculator. Root 10 times root 17.
Okay, that's 6.42.
Eh?
6.42.
6 K. What did you get? Press the answer for me.
That is 13 point something.
13.0.
13
Okay, 13.04. Okay, times what? Cos theta. Are you following?
Yeah.
So for me, what do you do now?
Right.
Then divide.
So cos theta is equals to minus 7 over 13.04. Abi?
Yes.
Divide both side by this. So divide this. What do you have? You say
Minus 0.53.
minus 0.1.
5368.
5368. So what do you do from here? Class cos theta is minus 0.5368. So that means that theta is equals to cos inverse of 0 minus 0.5368. So my theta class.
That's
1 to 2.55.
Eh?
1 to 2.55.
1 to 2 point what?
55
55 degrees. Is this clear? That's the angle between the two vectors. So the formula for angle between two vectors is what? What's the formula?
That
A dot
A
B
dot B
equals
equals
magnitude of
magnitude
A
of A
magnitude of B
cos
cos
theta.
theta. So you can use your calculator to find what? What can you use your calculator to find? Magnitude of A and B. You don't need to use your hand. Just sharp, go to mode. Change it to complex number, shift, absolute, and put your values. You get the absolute values, and from there you can get the angle between the two vectors. Tap that. Don't go, she's gone. Tap that woman. Don't go. Fight it. It's the devil. It's the devil at work. It's the devil at work. Is this clear? Is this clear? Is it clear?
Yes.
Let me give you one question.
Hey,
Let me give you one question, or two questions, or three questions.
I'm not really.
So we never stick there.
I'm not this for now.
No, Ajay.
The dot product of two vectors. 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 A of two vectors A of two vectors A equals HI. HI, yes. Minus 2J. Minus 2J plus 3K. H for happy. H for happy. Happy. H for happy. It's not happy that is H. A equals to, let me just write it. Are you still writing this?
Yes.
No.
A equals to HI minus 2J plus 3K.
3K.
Yes, 3K. And B equals to minus 3I minus 2J plus K. Minus 3I minus 2J plus K.
Alright.
Is 13. Find H. Is 13. Find H.
Wait, please answer the question. Is everything A and B equals to dot product?
Yes, read it. The product of these two vectors, blah 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 blah, is 13. Let's go. Number 2. Let me give you 2. Let me give you number 2. Number 2.
2.
You got minus 2 as the answer. And that's very fast.
Yeah, minus.
Okay, it's in the option. That's only as correct, sharp, but it's in the option. Minus 2. Ola has spoken. It's minus 2. Ask your neighbor. Neighbor said, all the neighbor that is dead, none of the answer.
Just times
No neighbor there, know the answer. See this neighbor, he has the question. Check this neighbor. Next question. Vector A and B are giving us, I'll solve the first one, don't worry. Vector A and B are giving us, vector A and B are giving us A equals to 2I minus 6J plus 3K. A equals to 2I minus 6J plus 3K. And yes, 2I minus 6J plus 3K. And B is minus 3, sorry, not minus. And B is 3I plus 2J minus 2K. Minus 2K. Evaluate A, B cross A. Don't spell cross. B cross A. Not by cross. B cross A B, theta, that's angle between the two vectors. Evaluate A, B cross A, B, angle between the two vectors.
That's it.
Yes, that's all. Should I give you one more?
Yeah.
Number 3. Yeah, so. This is I catch you.
Why laugh?
Give me your phone.
I'm down, Joe.
Let me go talk as a first.
It's not
6i.
minus 6i.
What's your answer?
6i plus 13j plus 20. How do you get 6i?
Minus 6i.
6i. 6i.
It's not
B
times.
times
It's
A.
B cross A. That's how you call it.
Minus
Times.
6i.
6i. It's not 6i.
It's minus 6i.
13j. 6i plus 13j plus 22k.
You guys should leave the people have blocks everywhere. Alright, let's solve that together.
Then the
That's
theta
inside.
is so my own is minus 6i.
Minus 6i, minus 13j.
Minus 22k.
Yes, that's
Yes.
That's what you got.
Yes.
That's what you got too.
Yes.
And did I know what you getting now? They're getting
I got
different answers.
6i.
B cross A.
Not 6i.
B
Not
cross
6i. Plus 13.
B cross A.
So the same person I go.
I'm getting.
Yes, minus 22.
I didn't tell her
It's
anything. Sharp.
not 20.
No, the way it's written.
It's
Let me make mistake. So I get 18. You got 18 at
yes. It's
19 be the answer. Now it's the rubbish. 18i minus 5g.
If I say no,
Right? Plus 22.
They play.
You know the primary
The
system.
first question, the first one says A equals to what? Equals to HI.
They have even solved it here.
Somebody have solved it now.
H is minus 2. That's the first one. The other one, but the person wrote 6i. 6i plus 10j.
13J.
But I'm not sure it's correct.
Minus 5g.
It's 13J.
What is your 3 times 3?
9 minus 4.
1 2
Alright,
times 2 is
listen.
2
Minus
times 2 is 4.
Oh, yeah.
9 minus 4.
So looking at this now, I have to find. They said the dot product. The dot product is what? 13. Abi?
Yeah.
Yeah, let's do this together. People are studying that one. Let's do this one together. So when you multiply, now to do the dot product now.
Yes.
That's A dot B multiply the component vectors. So H times 3i minus 3 give me what? Minus 3h, isn't it? This one will give me what? Plus 4, right? This one will give me what?
Plus 3.
Plus 3. And A dot B is
13.
13. So that means 13 is equal to minus 3h
Plus 7.
plus 4 plus 3. That's plus 7. Bring this one here. We're going to have 13 minus that will give me 6 equals to minus 3h. Divide both sides by minus 3. And your h will be equal to 6 over minus 3, which is what? Minus 2. That one is very, very simple. Everybody got that one. The next one, what do we have in the next one?
A
What do we have in the next one?
A
They
is
said,
2.
A is-
Yes, 2i minus 6j.
can I have this up, Abby?
Sure. Everybody got it. What we
Everybody got
thought?
that one. You know that
A equals to
A
2i
is
minus
2i
minus 6j
minus 6j plus
Plus
what?
3k.
3k. And B is what?
3i plus 2j
3i plus 2
j minus
J
2k.
2k. So find B cross A, not A cross B. Oh.
Yeah.
B cross A. So let's draw our usual stuff.
B.
This is I, this is J, and this is K. So what are the coefficients here?
B,
We
3,
have
2,
minus 6.
B,
Okay,
B, B.
B and A. Okay, so B is what?
3,
3,
2,
2,
minus 2.
And A is 2,
2 minus 6, 3.
Are we following?
Yeah.
Alright, so B cross A. B cross A is equal to, let's look at our I. Take out I like this. What's left? 2 minus this thing now. This
2
will have to
minus
solve it. 2 minus 2 minus 3 minus 6, 3. So do this minus this. So yeah, 2 times that will give me what? 6.
6.
Then minus
12.
This will give me
12.
Okay? Then minus J. Don't forget that J will always have a minus sign.
Minus 6 minus 2 is minus 12.
How do you get minus 6?
Huh?
Minus 6 minus 2 is minus 12.
Huh?
Minus.
Minus 6 minus 2 is what?
No, is that minus? It's minus 6. It's plus 6 now.
Plus 12.
You said it's 12 plus 6 now.
This thing.
What are they saying?
This thing.
It's plus minus plus now.
2 times 3.
But you could doesn't on this
2 times 3 is what? 6. Then minus. That one comes naturally. This times to give us what? Plus 12. So plus and minus. Minus will give me what?
They said 18.
So let's go. J. Take out this part. What do you have? 3 minus 2, 2, 3. 3 times 3.
9.
9. Minus.
Minus
So
4.
give me what? Minus 4. That will become plus 4. Are you following? Then for K, take out this part. You have 3, 3, 2 minus 6. This time you give me what? Minus 18. Abi?
Minus 4.
Then minus what? 4. So B cross A will give me, this is minus 6I. Abi? This will give me what? Minus 13J. And give me minus what? 22K. Who got this?
I got it. Minus 6 minus 6.
Alright, good. What's the one question?
Angle
The
between
answer
them.
is 114.57.
Hey,
The what?
The angle
The angle between them.
The angle between them. Angle
Yes, 114.57.
between them.
China.
A dot B is what? Magnitude of A, magnitude of B cos theta. Abi?
Yeah.
Good. What did you get as magnitude of A? Press calculator. What did you get?
Minus 12.
Minus 12. Magnitude of B is what?
No, magnitude of A is what's it called?
7.
I'm just saying.
And B.
B is what?
17.
Root 17. I don't have to use calculator to solve it now, Abi?
Yes.
You just use calculator to solve that. Exam. You don't have time to start solving. But if you want to solve it out, you just use magnitude of A is equal to square root of the x component square plus the y component square. Do you understand? So let's go. What about A dot B? What's A dot B? This.
The answer.
Give me the values of A here. What's A?
2i minus
2I minus what?
6j plus 3k.
6j plus 3k. What's A dot B? Multiply this part. What do you have? 6, Abi?
Yeah.
Minus
Minus 12.
12.
Minus 6.
Minus 6.
Minus 6.
That's minus
This
Minus
cancel this,
12.
you have minus 12. Can we solve now?
Yes.
So, if I want to make theta sort of formula, I'll be having cos theta. I can just say theta equals to cos inverse, Abi?
Yes.
Of A dot B over magnitude of A times magnitude of what? B. Are we together? Are we together, class?
Yeah.
So theta will be equals to
Minus 12.
cos inverse of A dot B is what? Minus 12 over magnitude of A. What did we get?
7 root B.
Root 17. That's 7 times root 17. So punch your calculator everything here. What do you get? Punch your
7
calculator.
times 3. 21.
Just
No,
do
7
this.
times 4.
Do this
28.
first, then press
20,
cos inverse of the
20.
answer.
That's 14.57.
Everything.
114.57. That's the angle between the two vectors. When I stop.
Gravity should be. So let's catch you online.
Wait, please, tomorrow.
So who wants to wake up by this time?
When I say you are
Please, it's starting by 2.
Ah.
It's starting by
I know that it's now you. Do you know where I'm coming from?
That 11.
No be 3 day calendar.
12 to 5.
Let's go and digest.
Don't be 3-day calendar. 12 to 5.
Let's go and digest.
Back.
12 to 5.
What do you want to do now? 7B. It should be enough now. Okay, because it's iPhone.
Let's take this question.
I'm surprised some people are scared.
Is it art?
Let's take this question.
This common composition, measure it, divide it, enlarge it.
Check 9 meters. 9 meters. Very Hey, very small. You have to break my boat. You break my bone.
The offense populated. That's the shit. That's populated. No, the compens are getting populated.
Then says find T1. Says find T1. I'll teach you a very simple method. A very simple method to solve it. There are different methods to solve it too.
Yes.
I can teach you like 1 or 2 methods. Yeah?
It's been on vector now. Yes.
Sorry? Yeah, under skill. Yeah, under skill and vector. Now, there's this method I usually use. It's called Lami's theorem. It looks like sine rule. Sine rule. Sine rule. Looks like sine rule. Where we have A over sine A equals B over sine B equals so that idea. Yeah. Now what do we do here? See, I can withdraw this diagram. There are 3 forces here. When you are seeing, you can see 2 forces already. Listen, this is a force. This is tension. It's acting in this direction, Abi? Yeah. This is also other tension 2 in that direction. We also have one more force. That's this force. That's the weight. Yeah. If I want to withdraw it, look like this. Do you agree? Yeah. What do we have here? T1. This is T1. What do we have here? T2. This is T2. And what do we have down here? This is the what? Force. The force. That's the weight of the object. Are you getting that? Look at this. The angle here is what? What angle is here? 90. This angle 90. Yeah. Are we together? Yeah. Good. If I draw it, let me just do something like this. A dotted line like this. This angle here is what class? It's 30 now. Yes. 92 here. So what I wrote on the board is 30. And if the angle is 30, see. If I draw a line like this. If I draw a line like this. Yeah? This angle here, they are listing. It's alternate to this angle here. That means here is also what? 30 degrees. And there is 30 degrees. This place here is what? 90. Abi? That means that everything here is what? Is 30 plus 90. That will give me what? 120 degrees. Are you getting what I'm saying? So if there's 120 degrees and here is 90, the remaining place will be what? Angle at a point is 360. So if here is 110 and here is 90, that will give me 210. 210 from 360 will give me what? 150. So that means the remaining angle here is what? 150 degrees. Do you understand that? Yes. Good. Let me make it. Do you see the diagram clearly? So we have 150, we have 120, and we have 90. So there are 3 vectors here. We have the T1, we have the T2, and we have the weight. Now what can we do? How can we solve this? We can solve this by using Lami's theorem, by saying this over sine this, do you get? Equals this over sine this equals this over sine. Do you understand that? Yes. So that means that W weight over sine 150 equals to T1 over sine 120 equals to T2 over sine 90. Do you understand that? Yes. Now, what do we have to find? T1. So I have no business with T2. Have we? Yes. Do we have the weight? Yes. What's the weight? 200. So that means I'll be grouping these 2. I'll be using these 2 to solve. Are you getting what I'm saying? So let's use those 2 values to solve. Shall we? Shall we? Yes. So let me solve it here. 200 over sine 50. What's sine? Sine 150 is 0.5. Check. Exactly. Yes. What do you get? 0.5. 0.5. equals to what? T1 over sine t. This one is 0.8660. Check. Am I correct? What's sine 120?
3 over 2.
Yeah, it's correct.
It's correct in decimals is what? 0.8660. So do your maths. Eh? Are we here?
Yeah.
Do you get what I'm doing?
Yeah.
Instead of saying multiply, if we're giving you big value, what do you simply do?
Just say 4.
Let's divide this one.
400.
Divide this will give you what? 400. Press your calculator. Equals to T1 over 0.8660. Are we together? Well, let's look at their option. Okay, the options is in short form. Hello, is in short form. That means that we have to express. Let's go back. Express this one here in what? In short form. Do you understand? Yes. So what is sine 120 in short form? That's 3 over 2. Are we getting that? Hello, are we getting what I'm saying?
Yeah.
So this part, what do we get here? We got 400 equals to T1 over root 3 over 2. So let's go multiply. T1 times nothing here, times 1, we give me T1. So T1 is equals to what? 400 times root 3 over 2. So people eyes are open now, but they're not seeing anything again.
200.
They are gone.
Like,
So
so, let us
2
go.
here will give us what?
200.
So I hate on serious today. I hate what you are saying. I don't like it. Let's go and see. Am I holding you? Is that guy not sleeping? Sleep now. Who's holding you?
He's not the best, don't worry. He's not the best.
Why don't I write in your one exams for you? Sleep. Shame me, I don't have sleep. I have to test tomorrow. An in-course test tomorrow. I'm not reading for it. I'm here with you guys. My people there are reading. I'm here with you guys.
Scholar.
It's a scholar. Do you think I don't have other things to do? If I don't hold it, will you beat me? Will you hold me that I can't sit down overnight? Will you hold me? Did I owe you an overnight? Talk to me. Do I owe you an overnight? Am I doing it for you? So if you want to sleep, then go and sleep. I don't want to hear that again. You want to sleep? Sleep. Nobody's holding you. When I'm done, I will leave. I will release you. When you feel like you want to sleep before I release you, then sleep. Be comfortable. Yeah. I'm bedrest. So let's go. T1 is equals. What's it going to give you now? 200. That's going to be 200 with 3 Newton. That's option C. Is this clear? No.
Sabi, let's solve my code because my code now I see more tougher.
No matter how they give it, because if it's something like this, just use that same. Just find the angles.
What if it's not like this shape?
No matter how it looks like. Just always look at this. Look at this other diagram. What does it look like? It's not the same.
It's not shape. Like this.
It's the same shape. It's always looking like 3. Always giving you 3. Always like that. I can solve this one. Should I solve this on that method?
No.
Yes.
Which try one? That one's hard.
What?
Have I shown you?
I've seen it in the past question.
Which one?
Do you know if it's the one in
Do you know the one I'm trying to say? They say I've seen it in past.
For you already
This is actually easy. It's not easy.
Let's stop it.
Wait, the other one might actually be.
Exactly.
I don't like this one. Let's go.
Let's try.
I know understand that.
Try straightforward.
Yeah. Acting on this one. Acting on this one. Yes. Opposite. Now, sign. When you're doing triangle now, this over that, this over that, this over that, this over. Do you understand? Yeah. Let me show you that method. Don't worry. This is the last one I'm going to use it today. After this one, I'll use you.
Wow. No chemistry.
I'll use you.
You are not doing chemistry.
What do you use Scalar again?
No. Don't sleep.
It's
only then I'll sleep.
Now listen. This weight, Abi. This weight now. See. I can reflect this weight like this. I can reflect it upward. See, let us withdraw. Watch. Let us withdraw. Watch now. We have this. What do we have here? C2. Isn't it? The weight is supposed to go down. If I reflect it up, it will not be like this, Abi. So that means this place is now what? Wait, are you seeing that now? But what's this one? T1 is going like this. If I reflect it here, it will be like this, Abi. I bring it up, it will not be here. T1, forming a triangle.
I like that.
So you just form a triangle.
Sir, continue.
Now why you
You see.
to refer exam for a pass?
So
So,
you see how I found that triangle?
Yes.
There was the angle here, 30, isn't it? What's the weight? 200. Now you see the one that you love now. This should find T1. T1 is T1 not adjacent. Are you following?
Yeah.
What's 200? 200 is not opposite. That's tan. So you can say tan theta is opposite over adjacent. That means that tan theta, tan 30, thank you, is what's our opposite?
200.
200 over T1. Abi? So if you cross T1, will be equal to 200 over tan 30. Press calculator. See, let's do it by hand. Let's do it by hand. So T1 is what you ask? 200 over tan 30. Tan 30 is what? Tan 30 is root 3. Is it 1 over 3?
No,
it's root 3. Root 3. So rationalize, Abi?
Yes.
Rationalize. So T1 will be equals to this will give me 200
over 1 over 3.
3 over
No,
sorry, this is
something
what,
is wrong there.
What is tan? Check. Press
think it's
what
1
is
over
tan 30?
It's 3 over 3.
With 3 over 3.
Tan 30 is root 3 over 3. Root 3 over 3. So that will give me T1 equals to 200
Times 3 over root 3.
times 3 over root 3. Abi? That will give me what? 600
Over root 3.
over root 3
Times root 3 over root 3.
That will give us
600 root 3 over 3 plus 200 root 3.
Hallelujah.
This one is nice. So
This one is simple, Jai.
So it's simple,
My
Abi?
belly.
Which one?
This other one.
Second one
I've
is
done the first one already.
This second.
both are good. Both are good.
You like this one, Jai?
this one is shorter.
Short and faster.
And faster. Forget everything I'm doing. So I want to use my hand. Any question?
I'm not taking enough from
See, forget that I use my hand. I use my hand is long here. Normally, from here, press calculator, you get the same answer. From here, straight.
I get that.
Do you understand? So this one is just the trick is that just look for how to draw a triangle. Let's see one. Let's see the last one then. We'll call it a day. Hope you enjoyed today's class. So let's can I have this solve?
No.
Yeah, sharp. Let's solve one question.
I think that's it.
Then we call it a day. For this one question, permit me to use the two methods. So you understand, it's best to understand the two methods, understand the two of them.
Yeah, permitted.
Because
You
one.
understand the two of them, even if you are using one, understand the two of them. So you now see, but sometimes you may be choked on one. You have to swap to other method. Maybe I'm using this one now. You're not choked at the point, so you don't know what to do again. Come on, sharp. Or maybe I'm doing this one, you're not choked. See, how will I do this triangle? Swap here, sharp.
I'll go do that first one.
This one, I would advise you to do. So triangle and use Okatwa, get to answer, sharp. So let's solve this question.
Yeah, something. Yeah, but that's not right.
So yeah. What's time, please?
That's not.
4:08. Try 5 o'clock.
Yeah, it's just for.
Did you write it? Give me the one.
You can clean it.
Give me first.
Everything is done.
I know him.
I know TFC. I don't have
Who said that is dying?
This is the question.
Tally my belly.
So for those of you online, I apologize for not using mic. I was with my mic today, I forgot it. I was with my mic.
Wow.
I got my mic. All this your voice, all this your noise. It's not sound. You'll not hear anything from you. People just be shouting, you'll not hear anything. It's only my own voice that be sounding. So I didn't bring my mic is in my back. I didn't bring it. I left it. Maybe next time. I will bring it along. So this is the weight. This is
It's that still now. Looking for my book.
the question says the tension in chord A in the figure is that.
Sorry.
Find the tension in chord B. The question says the tension in chord A is that. That means this A is what? 30 Newton. Do you understand? Find the tension in what? So find tension
In B.
in B. So permit me again to use the 2 meter. I'll use the first one, that long one first. It's not that it's even long or anything. I'll use that one first. So we can now use the other one. That method is to do what? To find all the angles.
Yeah.
All the possible angles. Are we getting that?
Yeah.
So now we know that this place is fixed. This thing, please. This is the last part. So we are done. We are done. This like we have tried. Like 4 hours now. We have tried. Okay, we have tried. So let's see. See.
Extend that.
This is 50. This is 50. Angle in a triangle is what? 180. Maybe it's 50, yes, 50. The remaining angle will be 80 because 50 plus 50 will give you 100. 100 minus from 180 will give you what? 80. So 80 plus 50 plus 50 will give you 180. Is that one clear? Good. Either place is, we have gotten one part already. Now what can we do? See. If I draw a dot like this, see like this, a straight line like this. This angle here is what? 50. Because alternates to this angle. Are you seeing that now?
Yeah.
And this angle here is what? 90. So everything here will be 90 plus 50. That's 140. Abi? 140, yeah. 140, Abi?
Yeah.
The same thing here. This angle here is what? It's 50 now. Alternate angle. And this one too is what? 90. Everything here will be what? 140. Let's check if it's correct. 140 plus 140. 280 plus 80. 360. So let's withdraw. Let me withdraw. This is A, Abi. What's A? 30 Newton. This is B. This is weights. Are you getting that? Into my arrow sign so that they are vectors. And the angle here is what? 80. The angle here is what? 140. The angle here is what? 140. Now I've gotten the angle. Now use that Lami theorem.
Yes.
That's this over this. Let's go. Weight over 8 over sine 80. Are you following?
Yes.
Equals to 30 over sine 140. Abi? Equals to
Both are easy.
B over sine 140. Are you seeing that now? What are we looking for? Looking for B, Abi?
Yes.
That means I will compare a complete set of data to B. I can't use this one, so it's out. So I'm going to be using 30 over sine 140 equals to B over sine 140. So this we cancel this, Abi?
Yes.
What do you have now? B. Some of you start pressing sine 140.
This costs 30.
Some of you start pressing sine 140. It's not the same thing. So to cancel out, Abi? So what do you have? B equals what? 30 Newton. Is this clear?
Yeah. Second one.
Yeah, right, sharp. Let me do the second one. Second method. Let's see if it's going to work. It will not work. It's even 37, even without solving it.
Yes.
I just look at it now. This triangle is what do you call that triangle? Isosceles triangle.
This one is just
That means that the two sides are also equal. This is a trick question. See now, base for isosceles triangle, base angles are equal. So base side, the sides too are also equal. So if there isn't,
that you don't need to solve it.
I will only solve it in case normally if they don't give you the same angle now. This is just a coincidence, they give us the same angle. But if they change the angle, you have to solve it out. Do you understand? But it makes sense. Not that it's smart. That's why I said smartness is the key to passing. When you see it, the student 30. Or bomb will just tell you is also what? 30. But as we solve it, does not agree with us. Even in mathematics, I agree with mathematics. You get the idea. So let's use that triangle and see if we get the same answer. Okay?
Sorry.
What do I get a triangle now? Yeah, that's the end of the Is that must stay with that?
Yes, sir.
I was boy. Yeah, it's so quiet. Yeah, I was boy, I swear. So you cannot. Never love my life.
So you know the name.
I've seen it before now. My guy have used it before, so I was like, I'm like, give me small now. Make I move set. How does that thing work, sir?
Relax, now I'm supposed to bite you.
Like, apart from see, what? It's better for muscles to just bite it. The annoyance is really to fly around. Fly around your ear. Fly around your hand.
Right and go. Which one another hand?
Okay, you want to stop blood. Why are you singing?
They'll come in groups.
No, they are telling you that I'm around though. That's
Suck your blood and rest now. Why would you suck your blood and be giving me music? Fuji. So let's go. Let's see the triangle. Let me start with this part. See this part. Sorry, let me draw it here. See this part. That's my B, Abby.
Yeah.
That's this part. Okay, this form a triangle.
This one, go
Down. Let's take it up. That's our
W.
Then obviously, this one is like this now. It will be something like this. Let me just draw it. Something like this, Abby? That's my A. So, but be careful of the angle. See this angle here is 50. This angle here is also what? 50, Abby? Yes. No.
40.
Yeah, the base angles. If this part, this, let me do that again. Let's draw this. Let's just draw this well. See, this place is my A. So this is my weight. So the base angles of A and B are 50 degrees. So if here is this is B, that triangle is confusing my head. Let's draw it like this. Okay, yes. Let's be like this. You get. Now this one goes like this.
Yes.
It will go like this. Do you see that?
Okay.
You get it. Let me withdraw it. I have my B like this. That's my B.
Yes.
That's this one, Abi? And I have my weight. It's going down, and if I reflect it, it will come up. So this is my weight. Do you agree?
Yes.
And the last one we have is what? A. That is like this. So this line is parallel to this line, Abi? I can bring this one, I can bring it like this. If you look at it now, it's the same, Abi? So I can bring this one like this. So this is my what? My A. Do you understand that? So the base angle of A and B. Look at the base angles here. So this is the base angle here. Here and here. Eh? You see it? You can see why sometimes you need to just learn the two methods. So in case you are hooked at one, you know what to do in the other. Do you understand? So that's this one is not from angle 90, right angle triangle. This is the base angle. This angle here is 50. This angle here is also what? 50. My weight is okay, we're not giving weight, Abby. My A is 30 Newton. Do you understand? So we can get my what? I can get my B. But in this case now, we still have to use what in this case? We still have to use sine rule. Sine rule will say this over the angle. What's the angle here? 80. The angle here is 80. So this will be what? From sine rule, this will be W over sine 80 equals to B over sine 50, Abi, equals to what? 30 over sine 50. See the same thing. Why we not use Sokatwa here? Because it's not from a right angle triangle.
How do you break it?
Out. Okay, that one is going very far. Here, bring it to 2. Okay, that's a good idea. If I'm bringing it to 2, this angle here will now be 40 degrees. Abi? Now the angle 90. So something will be angle 90. Something will be what? 40 degrees. I'm looking for what? For B. Abi? If here. Now, if I'm looking for, okay, I'm looking for B now. So you have to find this place. That's a long method. You have to find this place again.
First. That's what it is.
Find that place first. So now,
And to use the other method, not sine rule.
I feel like doing it to see if I want to get the answer. To get this place now, this is, someone said no, this is hypotenuse. Abi? And this is opposite. That's sine. So sine 50 is opposite. That's this place, let's call it x. X over 30. So x will be, help me out, 30 times sine 50 will give you what?
0.7. 7 what?
That is 222.98.
22.98.
Okay, when you multiply.
22.
Yeah.
So this is 22.98. And if you now use that to get b, this is opposite and this is hypotenuse. So sine 50 again. It doesn't make sense this way. If I use opposite as 22.98 divided by b, Abi?
Yes.
So b will be equals to this over sine 50. Check. 22.98 over that's
29.999.
that's 30. Oh, that's
a long
long
method.
To start dividing it again is a long method. So from just two sign you get. But if you divide it, it's mathematical. You still get the answer. See, you got the answer, Abi, but you are doing your objectives. So you have to find the shortest way possible. All right. So this will bring us to the end of today's class. Now I want us to do something. And some of you are new students, and this is back to tutorials. We run tutorials University of Lagos here for 100 level students, Monday to Friday. And on Saturday and Sunday we do marathon classes, 5-hour marathon classes. So I want something from us. One thing. You can see we are streaming this class live on YouTube. So I want us to go on YouTube, search for gravity_tutorials, gravity_tutorial, and do us a little favor by subscribing. Do us a little favor. It won't take more than 10 MB. You need 10 MB to subscribe. No, now. Just go to YouTube.
Less than 1 MB.
Go to YouTube. Please do that now. If you have not subscribed to the YouTube channel, please. It's not take you anything. Go to YouTube, type out gravity, put your underscore and tutorial. You see the logo. You see this logo this what I'm wearing. You see it. You see it. So you see this. Click subscribe, and also you can share the video. The video will be uploaded. This class is recorded, so you can go back to YouTube later. Are we here? You can go back to YouTube later and rewatch. Send to your friends. Okay, we had a class. We had a midnight class. You can watch. You can go through them and God bless you. So you can go and don't go home. Don't go home. It's too early. And hang around. Read if you still want to read. I'm going to read now. If you want to read. If you want to sleep. You can go when it is 5 or 6. Please call security, please don't go ahead. Alright.
Subscribe. I'll subscribe.
Tomorrow's class will be very These 6 hours is enough for you.
I don't show my fine face.
Go. Let's go. Good open eyes.